Hello, in this video we're going to talk a little bit about what Java actually is. So Java is a powerful general purpose programming language. It's very widely used. It's been around quite a long time now, and it will be around for a long time into the future. So it's a really great language to learn as your first programming language, or as your only programming language, because people certainly do make careers entirely out of Java. And whatever kind of program you want to write, there's a good chance that you can write it in Java. Just for fun, I Googled something like programs written in Java, and I found this Reddit page. What are some of the biggest and well-known Java applications used in the world? And you can see just from me scrolling through this that there are an awful lot of things written in Java, and it covers an awful lot of different areas. So what is a programming language in general? Well, basically, programming languages can be divided into two types: interpreted and compiled. In both cases, you write text files in your programming language. So Java is a language in a way, in the same sort of way that English or Greek or Italian are languages. That is, you can write down text in the Java programming language in any kind of text editor. You know, it's just some text. Then to get that to run on your computer, you need some other step has to happen in order to actually run that text as a computer program. So with interpreted programming languages, what happens is your text gets fed to a thing called an interpreter, which is just a computer program, and that actually does whatever the text tells it to do. Now, Java is not interpreted, it's a compiled programming language. That means that we take our text and we use some software to turn it into an actual binary computer program, which can then run and actually do things on your computer. So quite often in this course, I might mention compiling or building. Compiling means taking your Java text and turning it into binary files, which are actual computer programs that your computer can understand. Building means taking all the different binary files that you've created and building them or combining them into a single computer program. So I might tend to use these terms a little bit interchangeably, compiling and building, although they do mean different things. Don't worry about memorizing this at the moment. All I'm trying to do is reduce your confusion, not increase it. So I just want to run some of these ideas past you so that you've got a bit of an idea about what's going on here. So basically, we write Java programs as some text, and we compile them and build them into a program. And usually that's more or less as simple as clicking a button after we've written the actual text. Most of what we're doing is just going to be writing that text in the Java programming language. If you want to create a particular type of program with Java, so let's say you want to create Android programs, or you want to create websites or web applications, or games, maybe even you can create games in Java. Whatever you want to do, first you would have to learn basically the Java programming language, and then later on you could learn how to use Java to do the particular type of thing that you want to do. So if you wanted to create websites, first you've got to learn Java, and then you'd have to learn about creating websites with Java. There may be other things that you have to learn. So in the case of websites, you'd have to learn more about web programming generally. But basically, that's the idea. This course teaches you the Java programming language. So we'll be creating mostly text mode programs, which might not sound very exciting, but the thing is you'll be learning the Java language itself, and that will give you a very, very powerful sort of platform from which to then go and learn particular areas of Java that may interest you. Many people build careers just entirely out of Java. So beginners often think that they've got to learn 15 different programming languages, but you really don't. Lots of people just know basically one programming language, like Java or C++ or something, and they just stick to that programming language and they build a whole career out of it. So Although in this course, I'm not going to teach you how to create Android apps or desktop apps. We may touch on some specific things you can do with Java, and I may show you some basic little examples to get you started. But we're not actually going to be looking at any particular speciality. We are going to be looking at the Java programming language itself, writing text mode or console mode programs, we call them. But even so, you're going to be learning a very, very valuable skill here. And it's hopefully going to set you on a whole journey and enable you to do whatever you want to do with computer programming. Okay, so until next time, happy coding. Hello, in this video we're going to talk a little bit about how Java works. And once again, don't stress, there's no need to really memorize this, but you will gradually become familiar with these ideas, I think, as you continue to use Java. So I've already said that Java is a compiled programming language. We take text files written in the Java language, we turn them into binary files, and that's called compilation. We combine them together if there's multiple files. This is called building. And then we run them on a computer as a computer program. But actually, it's a little bit even more interesting than that, because Java does something rather interesting that many programming languages don't exactly do. And that is, there's this thing called the Java Runtime Environment, or JRE. And what this does is it's some software that creates effectively kind of like a simulated computer on your computer. And your Java program runs on that simulated computer. Now I'm simplifying a bit. Various optimizations mean that Java doesn't precisely run like that. Bits of Java code run kind of almost directly on your computer, but basically, to simplify a bit, it's as though your Java programs are running on a simulated virtual computer which runs on your computer. And that simulated computer is created by the JRE, the Java Runtime Environment. Now, the advantage of this is that Java is a compile once, run anywhere programming language. So with some computer languages like C++, you compile your source code, the code that you've actually written, and then it will only run on one particular type of computer. If you want to run it on a different type of computer, you have to recompile it, and maybe you even have to change it a bit to run on a different type of computer. The idea behind Java is that you compile it once, and that will run on any kind of computer that's running a Java runtime environment. So the Java runtime environment gives the Java program a kind of consistent environment to run in, regardless of the underlying type of computer. This is a very clever idea. So if you want to run a Java program on your computer, then you need to have a JRE installed. We won't need to specifically install this because later on we're going to install a Java development kit. The Java development kit includes a JRE, a Java runtime environment, so you can run programs once this is installed, but also it allows you to develop Java programs yourself. And all of these things are free, completely free. So we're going to move on to install a Java development kit, among other things, because we'll also need something to write our Java code in. Okay, that's it for this video. Until next time, happy coding. Hello. To get started with writing Java programs, you're going to need two things. You're going to need the Java software that actually creates your programs, and you're going to need some sort of editor to work in. So in this video, we're going to take a look at installing the software that actually will take the text files that you're going to write in the Java programming language and turn them into actual Java programs. And what you need is the Java Standard Edition, that's SE, Software Development Kit, SDK. So I'm going to search for Java SE SDK download. In this course, we're using version 11 of the development kit, at least to start with. So if I click on this link here that says Java SE Development Kit 11, then we go to the Oracle Downloads page. On this page, you have to be sure to check Accept License Agreement, and then you need to download the correct installer for your platform. So I'm actually using Mac, so I would download this OS X version. I'd use the 64-bit version. So if you're using Windows, download the Windows.exe installer, and you've got options for Linux as well. So you need to download that and install it. You probably won't encounter any problems as long as you have admin rights on your computer. If you do encounter any strange error messages or anything like that, don't be afraid to type the error message out into Google or into some search engine. Just Google the error message basically and find out what comes up, because other people will have had the same problems. But basically, you shouldn't really encounter any problems most of the time. So you just need to install the latest version of Java. If there's a later version out by the time you're watching this, so version 12 is actually already out. And the reason I'm not planning to start off using that is because there are relatively minor changes in version 12 of Java compared to version 11. It's not always the case that all the software you use will be compatible with the absolute latest version. So it's often not a bad idea to hang back a little bit from upgrading your version of Java, because otherwise you may run into incompatibility issues. So I'm following the policy here in this course of using a fairly recent version at the actual time that I'm making this video. So if you're watching this and version 14 is out or whatever, you can use version 14. But I'm going to stick with Java 11 at the moment, even though version 12 is already out. Okay, so try to install that, get that installed, and I'll see you in the next video. Hello, in this video we're going to take a look at installing Eclipse, which is an integrated development environment. So hopefully by now you've installed the Java SDK, and what you need is some kind of editor to work in, because Java programming is basically about creating text files. And in those text files, instead of writing in a human language, for example like English, you write in the Java programming language. And then the software development kit that you've already installed will, behind the scenes, turn those into actual Java programs. Now, you can write Java code in any kind of text editor, even in sort of Windows Notepad or Mac text editor, whatever you like. But there is specialized software designed to make it easy to work with Java code. So one good option, for example, would be to use an editor that's actually designed for programmers to work with, like a programmer's editor. And at the moment, I'm here at the end of 2019. Visual Studio Code is actually a great option, but we won't be using it in this course, and I will explain why. But if you search for Visual Studio Code, so this is not Visual Studio. Visual Studio is a what we call an IDE, an integrated development environment. But we're not going to be using that either, although I think you can. So if you search for Visual Studio Code, you'll find that this is actually an open source programmer's editor from Microsoft, and it's really, really good. It's really excellent. I highly recommend it. And you can install all kinds of plugins in it that make it work with various languages, including Java. Now, the problem with using a code editor to do your programming is that you've still got to somehow compile your programs. That is, you've got to take the text that you write and turn it into an actual piece of software and then actually run it. So one thing that probably a fair few Java programmers actually do is they will use a programmer's text editor like Visual Studio Code, like Emacs, or even Vim, something like this. And then on the command line, they'll actually compile and run their programs. I'm not going to be using the command line in this course, I don't think. And the reason for that is that I'm using a Mac and you may be using Windows or Linux or a Mac, I don't know. And the actual sort of command line commands that you would need to write in a console to compile your Java programs would be slightly different between different operating systems. And I want to make this course in a way that it's good for anyone using any operating system within reason. And another reason that I'm not going to be using the command line is that most professional Java programmers do actually use a thing called an IDE. Now, IDE stands for Integrated Development Environment, and that's a fancy way of saying a text editor that's specialized usually for a particular programming language. And it will also have buttons to do things like compile your programs. In other words, take the text and turn it into a program, an actual piece of software, and run the programs so that we don't have to mess around with the command line at all. And the one that we are going to use in this tutorial is a very excellent, very popular, completely free IDE called Eclipse. So I'm going to ask you to search for Eclipse for Java developers, because that's what we will be using. Eclipse, you can use it to write code in various programming languages. And of course, we want the one that's specifically configured to develop Java programs. So if you search for the Eclipse IDE for Java developers and go to that at eclipse.org, and then download the one for your operating system. I can see here it says a newer version of this is available here. So I'll just click on that link, get the latest version of it. You really want the absolute latest in this case. And download the version for your operating system and install that. And then all you have to do is start it up. Sometimes people find that there are error messages when Eclipse starts. Eclipse does depend on you already having installed the Java SDK, so you have to do that first. If you've done that and then you install Eclipse and you get an error message, again, don't be afraid to put that error message into Google. So if it says, no matter how obscure it is, if it says something like cannot find Java, then type into Google Eclipse cannot find Java or whatever the error message says, and see what the solution to it is. This initial few steps are particularly frustrating, or they can be. Hopefully everything will go smoothly, but some people are going to find that this doesn't go smoothly. And at that stage, it's really easy to just give up and say, I don't know what's going on here. It's too confusing. It's normal to feel confused at this stage, especially if you do encounter an error message. But you just have to get through this particular bit. And once we've got to the point where we can actually run Eclipse, write a program and run the program, and that's all working, then we'll have a lot smoother journey. So it's just this initial bit that's a bit tricky. So after you've installed Eclipse, start it up, and you should see something that looks like this. And Eclipse usually starts up with the screen that looks similar to this. When Eclipse starts, it might ask you to set your workspace directory. And what that is, it's just a folder where Eclipse is going to put your code. So you can create that folder in advance if you like, put it in your documents folder or whatever, call it workspace, call it anything you like, it doesn't matter. And then you have to just tell Eclipse to put your code in that folder. So in other words, you set your Eclipse workspace to that folder. And if you change your mind later, in one of the menus here, in the File menu, there's this option to switch workspace. and you can use that option to switch to a different folder. By default, it will be called Workspace, but it doesn't have to be. That's not important at all. So you can set that to wherever you like. Because I'm on a Mac here, my directory structure looks like this. It starts with a slash. On Windows, it will probably look a little different, but that doesn't matter. Okay, so hopefully you can get to this point where you can see Eclipse running, and then we don't need this. We don't need this whole screen here. So I'm just going to close it with the sort of cross in the corner here, or however you close Windows on your system. And then we'll see something that looks like this. Quite intimidating, but as you'll see, it's not so bad. We're going to learn it bit by bit. And by the end of this course, you'll feel, I think, fairly familiar with using Eclipse. Eclipse has an absolute ton of features, and you can even install more via plugins, but we won't need most of those features. So there's no need to be frightened of it. It is a bit intimidating when it starts up, but you'll see it's not so bad. Okay, in the next video, we will look at actually creating a Java program. And until then, happy coding. Hello, in this video, we're going to actually create and run a Java program. If you can get to the end of this video and you can actually do this and make it work, then you can really give yourself a pat on the back, because this is really something. To create your first hello world type computer program is really a great thing. It's really an important and wonderful step. And once you can do that, you're well on your way. So there are two ways I can create a Java project here. You may or may not have this, because different versions of Eclipse do sort of change a bit. But here it gives me an option that I can just click to create a Java project here in the area that we call the Package Explorer. So I can just click that, create a Java project, but I'm going to do it a different way that's more standard across different versions of Eclipse. I'm going to go to the File menu, and I'm going to go to New Java Project. If you can't see Java Project here, then go to Other. And when you click Other, you'll have a whole list of different types of project, and you just have to go to Java and select Java Project. So it doesn't matter, just do one of these, but your goal is to create a new Java project. Okay, so let's go back and do it in the way that is most common, at least as far as I'm concerned. I'll go to the File menu, go to New Java Project, and we get this screen here. We need to give the project a name. Now, usually that can be pretty much anything you like. This is just an Eclipse thing. It's not a Java thing. So there's no real rules about it. What I have found is that occasionally people run into problems if they have a space or some weird characters in a project name. Weird characters, I suppose, from the point of view of the kind of standard Latin alphabet. So what I'll do is I'll call this project Hello World. I'm giving it a capital H, capital W, but that's not important. It's just for readability. And I won't put any spaces in there, just to be on the safe side. So we fill that in. Another thing to pay attention to is the version of Java that we're creating this project for. So here it says use an execution environment JRE, and that's set to version 12 of Java. But that's not what I'm using. I'm using version 11. So I'm going to select version 11 here. This says here the default compiler compliance level for the current workspace is 12. The new project will use a project-specific compiler compliance level of 11. That's just kind of for information. It's not really important for what we're doing here. The compiler compliance level is actually, it's just talking about what version it expects your Java code to be. So it's saying that in this case, because I've selected version 11 of Java, we're going to be writing Java in a Java 11 type of style. Java is backwards compatible. So if you write code for version 8, it will still usually work it should work, I think, always probably, in version 10 or version 12. Okay, so you just need to make sure here that you have Java version 11 selected. And for most of what we're doing here, even version 9 would be all right. Version 8 of Java would be all right for most of it. And version 10 would probably be all right, maybe for the entire course. So you could even use version 10. You could use even version 8 for most of what we're doing here. Okay. All right, so we give the project a name. We make sure we've got Java Standard Edition version 11 selected. And if not, you can try playing around with these, but hopefully this will all go pretty smoothly and you can just use that there. Okay, click Next. So on this screen, the only option that we need to pay attention to is we've got this option to create module-info.java. Java modules are a fairly new addition to Java. They were added a few versions ago, and we're going to look at them later in the course, but to start with, we're not going to use them because they will only complicate things further. So I'm going to untick that. That's the only change that I'm going to make. Then I'm going to click Finish. Hopefully, you'll get a project generated now, and you can expand it and look into it. You will have included in the project, it will say JRE system library, should be version 11 here. That's just a load of stuff. It's a load of basic Java stuff. It's a load of sort of code that lets you build upon it to do things in Java, basically. And we've got this source folder, and the source folder is where our code actually goes. Now I'm going to select the kind of root folder there, Hello World. I'm going to right click it and I'm going to go to New Class. And I'm going to go back and explain this more in the next video. For now, we're just going to do it. So we need to create a new class in our project. I need to give it a name. And the name that I'm going to give it, I'm going to call it App. Now, that can be what you want, but I would suggest using app to start with just for consistency with these videos. It should have an upper class first name and the rest of the letters in it should be lowercase, unless you've got multiple words, in which case each word starts with an uppercase letter. But we'll be seeing more of that later. For now, just call it app, A-P-P. The package, we don't have to fill this in, but if we don't fill it in, we might get a warning. Packages, again, we'll be talking about those later on. They're just a way of organizing Java code, kind of like a folder, really. So for the moment, I just need to give the package some name. I might just use my initials, JWP. You can use yours. Now, the thing about the package is the letters in it should be lowercase. So I would say for the moment, just use your initials or whatever. You could even call it hello, something like that. Maybe I'll call it hello. But they should be lowercase, and for the moment, don't put any symbols or anything like that in there. And we'll talk more about packages later on in the course. Another thing I'm going to do is I'm going to tick this box to create a public static void main string array args. Now, of course, that looks incomprehensible to you if you're new to Java. That's fine, but tick that box. That's really important. So we've added a name for the class that begins with an uppercase first letter. We've given a package a name, and that's all lowercase letters, no spaces or anything. And I've ticked that I want to create a public static void main, and the other options, I've just left them as they are. And I click Finish. And then we've got our Java program. And in fact, I'll leave it here in this video, and we'll actually make this do something, I think, in the next video. Now, I know that this has a recipe book feel. I know that you don't understand what you're doing unless you're already a bit familiar with Java. You won't understand this. That's fine. It's normal. It won't be like that for the entire course, but we just need to get started. Okay, so until next time, happy coding. Hello, in this video we are actually going to run a program. Okay, so so far we've created what we call a class, and the class is a text file with the extension .java. It's in a particular location in our project. You should have something that looks kind of like this. Hello, there is the package, and in the package is a class called, in this case, app.java. I'm going to add some code in this class here, and then we're going to be able to run it. So here it says to do auto-generated method stub. So it's telling me that this is automatically generated, and I can replace this thing here with some code. So this is actually a comment. It starts with 2 slashes. If you don't have that, don't worry. The really important thing is that you need to write some code, and you need to write it in the correct place between these 2 brackets. We'll talk a little bit about the structure of this class, I think, in the next video. But for now, notice it says at the top it's got package and your package name. Then we've got public class and the name of the class, which is app. We've got 2 curly brackets. Now within those 2 curly brackets, we've got this public static void main string array args. We'll be talking about this. I know it's all horribly complicated looking at the moment. And within those 2 brackets here, that's where we need to write our own code. I'm going to get rid of this comment. It's not doing anything, so I'll just delete it. And in there, I'm going to write sysout, and I'm going to hold down on a Mac Command key, and probably on Windows a Control key, and I'm going to press the space bar. Actually, what am I saying? On a Mac, it's also Control. Hold down the Control key and press the space bar. And what should happen is it auto-completes to this. It says system.out.println, and there's a couple of round brackets and a semicolon. If for some reason autocomplete is not working in your Eclipse, you can maybe Google autocomplete Eclipse. Try and find out why it's not working. Hopefully it should work. It should be Control and spacebar, I think, pretty much on any operating system. So what that did, it simply takes a shortcut phrase, sysout, sysout, and it changes it into a bit of actual legitimate Java code. So that's just a way of avoiding typing this out, because we'll probably have to type this a lot, and it's just quicker to type sysout. But if you can be bothered, if you have the patience, you can just type system.out.println, 2 round brackets and then a semicolon. Now I'm going to click inside these 2 round brackets and put in 2 speech marks. And in fact, if I type 1 speech mark, Eclipse automatically puts in the other one for me. Now inside those 2 speech marks, I'm going to type hello world. And this is just text, and I can put what I like, but you have to be aware that there are some special characters, some kinds of punctuation, for example, like the / character, which if you type that in here, it won't work. You just need some ordinary text in there, and if you want, you can have a full stop or period, as you call it in America, and or an exclamation mark or whatever. Okay, that'll do the trick. Now I want to make sure that that is saved, so I'm going to go up to the top left here and click this Save All button. Then it sort of goes grey. Okay, so I've got my program and it's saved. There are several different ways you can run it. One way is make sure the file is selected, app.java, and click this green Run button. Another way is to right-click app.java and go to Run As. Hopefully you can see that, Java application. Just scroll down a bit here. So Run As Java application. And I get that menu by right-clicking it. But what I'm going to do is just select app.java and click the green Run button in the top left here. And if you do that, you should see some output at the bottom. and it should say hello world or whatever you've typed in those speech marks. If you don't see this console tab, you should see it when you run your program. And if you don't, in Window and Show View, you can click to make sure the console is actually showing. So that catches some people out. But if you just installed Eclipse, the console should be visible. So you see there's a bunch of tabs here. One of them's console, and that's where your program output appears. Okay, so if you try that, you should find that you can run the program by clicking that Run button, and it should say Hello World. If anything goes wrong, go over the video carefully, make sure you've done every step correctly. If you get any error messages, type them into Google or an internet search engine and just search for the error message and see what comes up, see what people suggest about how to fix the problem. Hopefully this will go smoothly. And when you've done that, you've run your first Java program. And I know you're going to be totally confused. And in the next video, I think we'll talk a little bit about this program and what it is and how it works. Okay, so if you can actually get it to run, that's a major step forward. It's really, really fantastic. And it is normal at this stage to feel very confused. Expect to feel confused. That's normal. Okay, until next time, happy coding. Hello, in this and the next video, I'm just going to talk a little bit about what we've actually created. And I'm not going to be able to explain all of it at the moment because there's just too much going on here for you to understand at this stage in the course. You will understand it later on. But for now, I just want to talk a little bit just to familiarize you a little bit with what's going on here. So you'll feel hopefully a little bit less confused. And if you've actually created your own program here and you've run it and it says hello world or whatever, then that's really a great achievement. So you should be proud of that. That's a fantastic start. Okay, so let's take a look at what Eclipse has generated in this video. So if you click your project and you right click it, so I should say click the project name in the Package Explorer here, and then right click it and go to Properties. And if on this dialog, if you've got Resource selected on the top left here, then where it says Location, that will show you where your project is located. And of course it's located in whatever folder you set the workspace to be. So actually let's take a look at that on the disk. So we'll go to it, and my workspace folder is this. I called it workspace, and you don't have to, but I did. And in there we've got a folder for the project, and it's called Hello World. It's named after the project. We click on that, and in there we've got a bin and a source folder. Now, you don't have to have these folders in the Java project. So if you have decided for some reason to follow this using, for example, Visual Studio Code, and you've looked up how to compile and run Java programs on the command line, then maybe you haven't created these. It is good practice to create them, bin and source, but they're not a part of the Java language. They're more like a sort of traditional standard in Java. The bin folder is where Eclipse puts your compiled programs. So when you take text files that contain text written in a programming language and you turn them into a program, some software does that, and the software is in your Java development kit. That process of turning text files into an actual runnable program that your computer understands is called building the program or compiling the program. These are technically different, but for the moment we'll just talk about compiling the program. So you're taking text files, turning them into an actual computer program, and that stuff gets put in the bin folder. And you can look at it if you want, and you'll see an app.class file in there. That's what's actually being run when you run your program. Now in the source folder here, that's where we put our source code. The source code is the stuff that we're writing. And in there, there's a folder called hello. The reason I've got a folder called hello is because I called my package hello. When I created this app.java class, which is what this is, this app.java is a class, I put it in a package called hello. So there's a folder called hello. Don't worry about these terms at the moment. I'm just beginning to use them so you get a feeling of familiarity with them, but you don't need to know exactly what they are at the moment. It's okay. So if we go into the hello folder, there's my app.java text file. That's what we've actually written. And that's this text file here. Okay, so what we've got is we've got a project located in the workspace. The project has one package in it called hello, so that's in its own folder. And inside that folder is a text file, app.java, and a text file has Java code in it that defines a class. And that app.java gets turned into a class file, which is located in our bin folder. So it's worth having a look at that in Windows Explorer or Mac Finder or whatever you're using, your File Explorer. Just have a look at this, just to feel a bit more familiar with it. In the next video, we'll talk a little bit about the code that we've actually written. And all of this stuff, I'm just giving you a very rough overview. You don't have to really understand what I'm saying in any depth. I'm just beginning to familiarize you with it, but we will be going over it a lot more in the rest of the course. Okay, so until next time, happy coding. Hello, in this video we're going to talk a little bit about the code that we've actually created. Now, there are a lot of concepts packed into this short piece of code. It's very cryptic looking, even though it's a basic sort of what we call a hello world type of program. You won't understand all of these concepts until you've gone through more of the course. So what I want to do here is just run through it quickly so you have a vague idea about it, just to try to make you feel a little bit less confused. It's not important to remember or memorize what I'm saying here, because my entire object is really not to teach you stuff at this point, but to reduce the confusion, more like. Okay, so let's just talk about this a little bit. So Java code is organized into packages. We create text files with the extension .java, and we group them together in what we call packages. We created one package called hello, and that's why this app.java file starts with the statement package hello. It finishes in a semicolon, and that's very important. Many programming languages use a semicolon to end a statement, and a statement is it's like a sentence in English. It's a little bit of computer code that does one particular thing, and it ends in a semicolon. Following that, we've got a definition of a class. A class is like the basic unit of Java code. You can have multiple classes in one text file, but usually, most of the time, you create one class per text file in Java. And usually the class has to have the same name as the file that it's in. So that's why we've got a class here called app, and it's in a file called app.java. Capitalization is also very important. Class has to have an uppercase first letter, and so does the text file that it's in. You can't have spaces or weird punctuation in it or anything like that. So we've got a class here, and curly brackets define what we call the scope of the class. They define the contents of the class. Within the class, we've got a single subroutine. That's a block of code that contains a bunch of statements that actually accomplish something. Now, this is a subroutine called main, and in Java, subroutines, sort of collections of lines of code, are called methods. So what we have here is a main method, and the main method is where your Java program starts. It's where it starts running from. This says string array args. We'll be looking at all of this stuff later, so don't worry about it at the moment. But this would allow us to pass in information from the command line if we are running this program on the command line. It's a collection of bits of text essentially, but it doesn't matter for the moment. So we've got this main method, this main subroutine, and the scope of that is again defined by two curly brackets. So there's a method called main, and then we've got some content of it that goes between two curly brackets, and all of that is nested inside this class definition. And what is the actual content of our main method here? Well, it's one single statement, and this says system.out.println. Print in programming terminology means to display on the console. So when we talk about printing text, and we don't mean anything to do with an actual printer, we just mean display it on the console, print it. So we've printed Hello World on the console down here. I don't know if you can see that down here. There we go. We printed that text. The text that we wanted to print is enclosed in double quotes here. So this is just normal, ordinary, human-readable text. The only unusual thing about it is that there are some things you can't put in there because they have a special meaning in Java. So for the moment, just stick to ordinary text, but you can have spaces and things in because between these double quotes, it's just ordinary text. And that, because this is a statement, this bit here, it finishes with a semicolon. System.out.println, println, it says, it's a mouthful, and we'll look at, you'll understand more about what that is later on, but just understand for a moment that this is how we display text on the console in a Java program. That's all it is. This actual text is called an argument to this method, println. So that's some terminology for you, and maybe it gives you a very vague idea about what this program does, or maybe not. Maybe you just feel even more confused than to start with. Either way, that's okay. That's all right. What we're going to be doing in the next few videos, and for quite a while probably, is just adding more text here. We're going to add more lines in so that we can do more stuff, and we're going to look at the real basics, the real fundamentals, the nuts and bolts of computer programming, and we're going to gradually build up your skill level, and hopefully you'll gradually feel less confused. It is really important to type this out though. You have to type stuff because just watching the video won't be enough. Okay, so until next time, happy coding. Hello, in this video we're going to talk a little bit about the main method, and we're going to add some more statements to our main method. So far we've got this program here. All it does is when you run it, it outputs some text, hello world in this case. Let's recreate that program, and it's a really good idea to try yourself creating basic Java hello world programs from scratch, because you want to sort of drill that into your mind and memorize it. So we go to File, New Java Project, and give it a name. Let's call this main method. So I'm going to check that I'm using Java 11 in this case. Click Next. I don't need a module, so I'll untick this and we'll click Finish. Then, without even expanding the project, I can just right-click it and go to New Class. Let's call the class App. We can call it more or less anything as long as it's got an uppercase first letter, and no spaces or punctuation or anything like that. The package, I'm going to call it application. This has to have a lowercase first letter. And I'm going to tick to say that I want a public static void main. And I'm going to click finish. Then finally, I can add some code to my main method. So between these two inner brackets here, I'm going to delete the comment. I'm going to type sysout and I'm going to type, well, hello world again, let's say. So notice I'm indenting the code within brackets. So this code is indented within these brackets using a tab in this case, and this code here is indented within these brackets. We're going to talk more about that in the next video. Let's just run it and check it works. It's a good idea always to try running your Java projects early on to make sure there's not some misconfiguration or anything. And there we go, it says hello world, just like the other program. So let's have a look at this. So I want to focus in this video on this, the main method. So a method what we're doing here is object-oriented programming. So Java is an object-oriented language, and it's hard to understand what that is until you know what an object is. So we'll leave that for the moment and tackle it later. But in object-oriented programming languages, subroutines are known as methods. This is an example of a method. It's a method called main. And what a method is, it's a block of code. So it's a collection of statements like this one. This is a statement. It ends in a semicolon. And in this case, the main method is very special because it's where our Java program starts executing, starts running, in other words. So when you run a Java program, what gets run is the content of the main method. Now we can put more statements in here. Have a go at this yourself, maybe either pause the video or after the video. Let's add a new line, and Eclipse helpfully puts the cursor in an appropriate place usually. So we want to make sure that the statements that we write here are lined up with this system.out.print line statement. Let's add another one. So sysout, control space. This is another line of text. Don't forget those speech marks there. So if you type one, Eclipse puts in the other automatically, usually. And don't forget the semicolon either, because it won't work without this semicolon at the end. Let's run that, and we should get 2 lines of text like this. Here we are. We can put more in. Let's put one more in. Let's write sysout and final line of text. You can type what you want within reason, really. And we'll run that again. So let's run it. There we go, and it looks like this. Try that out. It might not seem like much, but we're building up gradually, and it's going to get hard enough later on, so you want to really get these basics down. Notice I've left a blank line there. I don't have to. We'll talk about that more in the next video, but space within a Java program is not important. We could also write it like this, and that would work just as well. Let's run this. So the important sort of takeaway message for this video is when your Java program runs, the Java runtime environment will search for a main method, a method called main, and that's what this is. In other words, a subroutine, which has the sort of correct syntax and is called main. And then it's going to run the statements within main, and it's going to run them in the order that you see them. And this can get a lot more complicated, as we'll see later on. But for a simple program like this, we're just going to step down the statements here. They're going to get run one after the other. So first that, then that, and so on. In the sort of initial part of this course, we'll stick with just writing code here. And later on, we'll see what else you can do with methods and classes and objects and all that sort of thing. So try that for yourself. Try putting space in or no space. Have a go at it. Put some more lines in your main method and run it. Okay, so that's it for this video. And until next time, happy coding. Hello, in this video we're going to talk a bit about formatting, and this is an incredibly important topic. we're soon going to go on to look at the fundamental nuts and bolts of programming. But it's important that we get this right at the start. There are some things that we must get right before we really even begin. And this is one of them. So let's create a new project. Let's go to File, New Java Project. I won't keep doing this with every video, but I'm doing this just a few times because it is important that you remember it, and do try it yourself. Let's call this formatting, and make sure I've got Java 11 selected. Click Next. Untick Create Module Info because we're not going to use that now. Click Finish. And right-click the project that's been generated and go to New Class. Let's give it a class called App and put it in a package called Application, and tick to say that I want a public static void main. Click Finish. Okay, so we can add some statements to this. Now, I want to just point out Java is a programming language that has been influenced by various other programming languages. And two particular influences on Java were C and C++. So in Java, if we create a statement, let's write sysout hello. So this is a statement. It's kind of one piece of code that does something. And it finishes in a semicolon. And that idea of finishing statements with a semicolon comes from C and C++. Maybe there are other languages that use that idea earlier, but as far as Java is concerned, this is a C or C++ thing. And C and C++ were two programming languages that have been around for absolutely ages and are still extremely widely used. Similarly, these curly brackets, they're a C and also a C++ thing. So they come from these other programming languages, as do many other things in Java. Now, there are fundamentally, basically two different ways of formatting your brackets in these programming languages. So one way is when you open a curly bracket like this one here, or this one here, one style puts each opening curly bracket on its own line like this. Now you can use that in Java, but I don't recommend it because by far the most popular style in Java is to put the opening curly brackets on the same line as the sort of code that identifies what's about to happen in these curly brackets. So the curly brackets and the code within them, we call it a code block. And code blocks usually have something written before them that basically says what they are or what they do. So we put the opening curly bracket on the same line as that bit of code that says basically what's going to happen essentially in the code block. So I recommend you use this style, and Eclipse makes it easy to type code like this anyway. Space doesn't really matter in a Java program. You can put blank lines in. Let's type sysout, how are you? You can put them in where you want them, and you basically just add blank lines for readability. I am a computer. So that will run. And we could also do it without so many blank lines. On the Mac here, I can use Command D to delete an entire line, and I think on Windows probably Control D will do the trick. That's a handy shortcut. So put blank lines in and use space generally to make your program readable. Strive always to make your program look beautiful, and look logical and readable. Okay, so we're going to talk about auto formatting in the next video, and we're going to talk about indentation, which is a very important aspect of formatting. So until next time, Happy coding. Hello, in this video we're going to take a look at auto format, which is really important and very, very useful. So hopefully by now you've created a program yourself with 3 lines in it or more, however many you like, and we'll use that to talk about formatting. So we've seen that if you have curly brackets like this, an opening and closing curly bracket, that's known as a code block. So we have a code block here, and there's another code block here. Now, when we put one code block inside another, so this code block is inside this code block, and here we have statements within a code block. And when you put code inside a code block, or you put one code block inside another, it's really important to indent it. So you see that all the code within these curly brackets is indented by one tab, and all the code within these curly brackets is indented by another tab. And although that's cosmetic, so the program works without it. Let's try this. It's nevertheless extremely important to get this right, because if you don't have correct formatting in your code, it will be very, very difficult to read. It will look a mess. So always strive to format your code nicely and pay particular attention to indentation. Make sure that you indent one block of code within another, like this. You might have seen an American TV series called Silicon Valley, and in that, the protagonist is a computer programmer, and at one point he has a girlfriend who's also a computer programmer, and they have an argument and they end up sort of splitting up because they can't agree about whether it's better to use spaces or tabs to do indentation. So to indent some code within a code block, let's take this as an example. You could use 4 spaces. Typically it will be 4, 1, 2, 3, 4. And you can also use a tab like this. I just press the tab key there. There are pros and cons to both of these. So it can get annoying to have to keep typing spaces, and even hearing people typing spaces. You know, that can get quite annoying by itself. But spaces tend to have a consistent appearance across different editors. This is probably less important now than it used to be in the past, but I think it's still true that spaces give you better consistency when you write code in one editor and load it into another. On the other hand, they're annoying to type, and that's why I greatly prefer tabs, because just one tab can indent your code. So this will be indented 2 tabs because it's within 2 code blocks. It's within that and within that. So I recommend using tabs to indent your code, but if you are working with a team of programmers and they were all using spaces, you should use spaces instead, because the worst thing you can do is mix tabs and spaces. That tends to mean that when you load code written in one editor into another editor, it will lose its formatting and it will get out of line. So pick one of these, 4 spaces or a tab, to do the indentation and stick to it. Many editors these days will allow you to change spaces into tabs if you want. So I'm sure you can configure that in Eclipse. You can make it change a tab into a space, and also into 4 spaces, sorry. And also Eclipse helps you. So if you type a line, so if I'm at the end of this line here and I hit return, it puts the cursor in the right place so that we don't have to worry too much about indenting. So that's very helpful. Now, here's the most important sort of takeaway message for this video. You can automatically format your code. So let's put maybe a bracket in the wrong place here and put excessive spaces in and maybe indent this too much. If I select app.java, right click it and go to source and where are we? Source and format, it automatically formats my code for me. It will take out duplicated blank lines, and it will line up brackets and stuff like that. And that's incredibly helpful. Not only because it makes the code a lot easier to read, but also because if you made a mistake there, so if you've maybe missed off a bracket and you try to format it, then it won't format, or the formatting will go a bit strange. And that's really helpful for spotting where you've gone wrong. Let's put that bracket in again. Also, you can see an error down there. There's a red error marker that appears if you've done something wrong. This says insert bracket to complete class body in this particular case. Let's put that back in. Now, you can also format using a keyboard shortcut. I strongly recommend that you memorize this shortcut and you use it constantly. Some people think that beginners are better off using a text editor that doesn't have auto formatting, and the reasoning is that that forces people to really learn to do the formatting themselves. But in my experience, if beginners use auto format a lot, they gradually become used to the formatting. I think that's the quickest way to learn it. So I'm going to be suggesting that you auto format your code constantly, do it all the time. And the way that we do it, as we've seen, we could right click and go to source format, but it's quicker to use a keyboard shortcut. And on the Mac, that's Command Shift F, and on Windows it's Control Shift F. So here I'm using a Mac, so I'm going to, with one hand, my left hand, I'm going to hold down Command and Shift, and with my right hand I'm going to just press F, and that's formatted my code for me. Let's try that again. So Control Shift F or Command Shift F on the Mac. Great. So it's important to do that all the time. Do it constantly. Try to write code in the first place that's formatted nicely, but also use auto format constantly to check that your formatting is okay. And eventually this will become second nature to you because you'll be doing it all the time. And that really, really helps to make code that's easy to read. And it really, really helps to keep basic errors out of your code. Okay, so until next time, happy coding. Hello, in this video we're going to start looking at variables, and variables are one of the most important basic building blocks of computer programs. So we'll get started with them here. I've created a project called integer variables. I've given it a class called app, which has a main method, and I've put one statement in there. It just says hello. So you should try that for yourself and check that you can run it. And then let's add some more code to this. So what I'm going to do is I'm going to actually click after the opening bracket here and hit return a couple of times, just so that I can get a couple of blank lines above this statement and after the opening curly bracket. And here I'm going to type, well, we need a name for our variable and we need to think about what it's actually going to refer to. A variable is it's kind of a way of referring to some sort of value or some sort of entity that can change as your program progresses, and that's why it's called a variable, because it varies. Let's imagine that you keep cats and you've got some quantity of cats in your house. So what we want is a variable that can hold the number of cats we've currently got. Maybe sometimes your friend takes some of them, or you acquire more cats. So the number of cats that you've got can change. Okay, so I'm going to write here int, and then a space, and then cats, and then a semicolon. So what's going on here? Well, first of all, let's deal with this yellow warning. So you see there's yellow underlining here, and in the margin there's a little yellow icon, it's like a light bulb with an exclamation mark in this version of Eclipse. If I hover over it, it says the value of the local variable cats is not used. What it's telling me is that I've created a variable, a thing called a variable, and I'm not using it, and that's true. So warnings are things that you might want to pay attention to in your program. You don't really want to have any warnings in your program when you run it. But unlike an error, a warning won't stop your program actually running. So I can actually run this program still. It does actually run. So if you see a red icon here, well, there's red underlining, that's an error. And an error is a problem. It will stop your program compiling. You won't be able to run it. But this is just a warning, so we can run it. Okay, now what have we done here? Well, this is a statement, finishes in a semicolon. And we've essentially said that it's a bit like creating a sort of bucket in this case. It's a bucket big enough to hold numbers, and it's the right type of bucket for holding numbers. If you wanted to hold text or something, we'd need something different. So int is, we call it the type of the variable. And int is a primitive data type, we call it in Java. And cats is just a name I've made up. It's like sticking a label on a bucket and writing cats on it. So we've got our bucket, which can hold numbers because we've used the keyword int. And we've stuck a label on that bucket and written cats on it. Int is short for integer, and integer just means a whole number. It can be positive or negative, but it's a number. So we can assign a value to that. Let's do this. So I'm going to go to maybe the next line and write cats equals 7, semicolon. What have we done now? Well, we've taken the number 7 and we've stored it in this variable. Or we say that we've assigned the value 7 to this variable. And it's like taking the number 7 and putting it in our bucket. This is going to seem confusing at first, but after you've practiced it a bit, it won't be. And finally, let's output this value. So I've got system.out.println here, and I'm going to get rid of this text. So get rid of the stuff in the speech marks. So it looks like this. And then between these round brackets, I'm going to type cats. So we're saying display the value of this variable. Let's click run. And then it says there in the console, it says 7. So just to go through that again quickly, we wanted a variable that can refer to a number. And we've written int, that's short for integer, because we want to create some space in the computer's memory, essentially, that can hold a number. And this process here, we call it declaring a variable. And really, it's like creating a bucket of the right size and type to hold a number, and then sticking a label on it and writing cats on that label. Here, we've assigned the value to the variable, and that's a bit like taking the number 7 and putting it in this bucket. So we say that we've assigned a value to the variable cats, and that value is 7 that we've assigned. And then finally, we've printed the value, so that comes out on the console. Try this for yourself. The order matters. You've got to have these in the right order, and check that you can get this to work. And then we'll see what we can do with variables. So until next time, happy coding. Hello, in this video we're going to take a further look at variables, and we're going to look at adding numbers together. If you feel confused at this stage, that's absolutely normal. You probably should feel confused, but things are going to get clearer as you go through the course. As long as you practice what we're doing, it's very important that you try this out for yourself. Incidentally, you might wonder what kinds of variables there are in Java, and we're going to be looking at that in the course. But for now, I just want to direct your attention to a page. If you type into a search engine, Java primitive types, and maybe click on one of these links. Let's go to the sort of official Oracle documentation, primitive data types in Java. And you can see here, you don't have to read this or anything, but you can see that there are various types listed, and int is one of them. You can also see that it has a maximum value that we can put in it. That's 2 to the power of 31 minus 1. There's a reason why it's such a strange kind of value, but we needn't go into that. And the minimum value you can put in is minus 2 to the power of 31. Okay, don't worry about that though. Let's have a look then. So what can we do with this? Well, one thing we can do is addition. And in fact, the way I've written this here is unnecessarily verbose. We can do this more briefly, more quickly. So I've declared a variable here. I've declared a variable called cats. And here I've assigned the value 7 to the variable cats. We can do that in one single step. Before we do that, let's create a duplicate of our project. And if you're working on code and you've got something that works, and then you don't want to disturb that, or it's possible that you might mess it up with how you're about to change it, it's a really good idea to take a copy of it. Either that, or you could use a version control system like Git, for example, but we're just going to make a copy. So I'm going to right-click my project and go to copy. I'm just going to click in a blank space in Eclipse in the Package Explorer, right-click and go to paste. And we can give this a new name now. Let's call it addition. And click copy. So now we've got a new project. I would recommend creating projects from scratch until you feel completely familiar with that, rather than just copying projects. But anyway, so let's run that. So I'm going to select my app, click run, and it runs just as before. But now let's delete this int cats. And so now we've got an error. Why have we got an error? It's because, let's hover over the error. It says cats cannot be resolved to a variable. That's because I'm trying to output the value contained in this cats variable, but I haven't declared the cats variable and I haven't assigned a value to it. What we're going to do now is declare it and assign a value in a single step. Now this has to be above where you're using the variable. So wherever you use a variable, above that somewhere in your code, you have to declare it. So let's write int cats equals 7. So I'm declaring it and I'm assigning a value to it in one single step. Remember, your program is going to execute line by line. So it's going to go down your code block here. And that's why we've first got to declare a variable before we can use it. It has to be above because this is going to get read by the Java runtime environment before this is read and executed. Okay, so that will do the same as the program we had before. We can run it and it just outputs 7. Now let's say we've also got dogs. So let's write int dogs equals, let's say we've got 5 dogs, and by some miracle we can stop the dogs eating the cats. Again, we've got a warning because we've not used the value of dogs yet. What I'm going to do is add these together, and to do that I need a third variable. I'm going to type int total equals cats plus dogs. And then using my system.out.println, I'm going to output the value of total. It should be 12. So let's run this. And down here we have 12. What have we done here? So we declare a variable called cats and assign the value 7 to it. We declare a variable called dogs, assign the value 5 to it. And then we declare a variable called total And the value that we assign to total is the number of cats plus the number of dogs, and then we output it. Try that for yourself. It is easy to make mistakes here. So for example, you can't have two variables called cats in your code block here. If we try that, we get an error. If we hover over that error, it says duplicate local variable cats. Let's delete the second one. In fact, in Eclipse, if I just put my cursor on a line, and then in the Mac, if I do Command D, or in Windows, I think it would be Control D, that deletes the line. So it's quite a handy shortcut. Control D or Command D to delete a line. If I'm giving you any of the wrong shortcuts for Windows, you can always type into a search engine something like Eclipse shortcuts, Eclipse shortcut keys, something like that, and you'll find a whole list quite easily. Okay, so try replicating this program. Try changing these numbers to different numbers and see if it still works. You can also try giving them different names, so they don't have to be cats, dogs, and total. You might run into problems. You can't have spaces in variable names. You can't have punctuation in there. You should always start them with a lowercase first letter. That is very important. Without that, your program will work. So I could write total here with a capital T, and it would still run, probably. Well, it would do if I have to change both of them, of course. Well, that's not obvious. Let me explain that. Let's run this. So that works with a capital T on total, for example, or I could put a capital C cats or a capital D on dogs, but it's very bad practice. The standard in Java is that variables start with a lowercase first letter. So if you're using the conventional coding style in Java, which we are, you should always start your variables with a lowercase first letter. Don't do anything crazy with them. For the moment, just keep them all lowercase. And notice that Java is case sensitive. So a variable called dogs with a capital D is different to a variable called dogs with a lowercase d. See, that's only a warning. Whereas if I had lowercase d, I get an error. Seems to be some street cleaning taking place outside. Apologies for the noise. Okay, anyway, so let's get rid of that. What we want to aim for at the moment is creating legal, reasonable code written in the standard style. So create something that looks like this and try it out. And try tweaking it, change the numbers, change the variable names, see if you can get it to work. And don't forget that if you change cats here, you have to change the name of it here as well. The same for all of these variables. You have to be consistent. Okay, have a go at that, and until next time, happy coding. Hello, in this video we're going to take a look at outputting variables. So far we've got this really simple program, and I've created a copy of this and I've called it outputting variables. So maybe create a new program yourself, and we're going to change this code. Okay, so one thing I should say here is that it's really valuable to just type stuff over and over again. I think it's too easy to imagine that programming is primarily an intellectual exercise. Of course, it is an intellectual exercise, but a lot of the learning that you need to undertake is kind of related to your fingers. You have to get into the habit of typing things and getting used to typing them. And you sort of develop a kind of almost a muscle memory, and you get used to just typing particular programming constructs. So rather than copy your last project, always type it out again for the moment. If you want to really accelerate your learning, learn to touch type without looking at the keys, and you can find lots of programs on the internet to help you with that. But anyway, okay, so I've got this program here, and we're outputting the value total, but I can actually add some text to that. So within the round brackets here of system.out.print line, I'm going to write total number of animals. Let's put a colon there. This is just text, and then a space, and then I'll close the speech mark like this. And then after the closing speech mark here, so after this, I'm going to put a space and a plus, space, and then total. Now, before we discuss what this is, let's see it running. Let's run it. And it says total number of animals, 12, which is much more helpful. If you're actually going to write a program, for example, I don't know, to help you calculate something, help you do your tax, whatever, obviously it's very useful to output text with your numbers. So we've already used a plus sign here, and what this plus sign did was it added the values stored in these two variables together. Or as a quick way of saying that, I could say that it adds these two variables together. It adds the number of cats and the number of dogs, adding cats and dogs. These two variables are both of type int or integer variables. Now what we're doing here is something different. The plus sign actually has a different meaning. We've got some text here, and we are adding an integer to it. So you can't add text to integers. You can't add like the word giraffe to the number 13, let's say. It makes no sense. What this is actually doing is it's turning this number into some text and concatenating it with this text. So it's essentially joining the number to some text. It's kind of a text operation. And the result is what we see in the console below, which is this. We can also output, so after we've declared the variables and given them values, we can output all of them if we want. Let's write that. Let's try that. Let's write sysout control space and number of cats and plus cats. Notice that I left a space before the closing speech mark. Everything within the closing speech mark, within the speech marks, is just text. So even this space is just some text, but it looks nicer when it's output if we put space there, because we get this nice space here. And it's really important to strive for legibility and beauty in all of your coding. It'll make it a lot easier. So if I write number of cats and then plus cats and then output that, let's run it. So it says number of cats 7, total number of animals 12. Let's output the number of dogs as well. So I'm going to write it here. Number of dogs. One thing this is really useful for is helping you to get bugs out of your code, because whatever variables you have in your program, you can quickly output the values of them just using sysout, system.out.println, and that can be very, very helpful. So now we're outputting the number of cats, dogs, and the total number of them. Let's take a look. There we go. And let's also add some other number of animals in here. So I could write int. What else would you keep in your house? Maybe some people keep rats. I don't see how it's going to be possible to keep all these animals from devouring each other, but anyway. So int rats equals, let's say we've got 3 rats, which is 3 too many in my opinion, but you know, each to their own. So we've said int total equals cats plus dogs. We can just add another plus there, and we can write rats. We can add them all together, cats plus dogs plus rats. Let's output the number of rats as well, since we've output the number of cats and dogs. Number of rats and plus rats. So we're just using this plus to join the number of rats with this text here. Okay, finally, let's try this. And there we go. We've got number of cats, number of dogs, number of rats, and the total animals is 15, which is too many, but there you go. Okay, try this for yourself. Experiment a little bit, add stuff together. It doesn't have to be animals, can be whatever you want. The important thing is to type it out and create your project from scratch as well. Don't copy it. Copying is useful, but at this stage, the important thing is to get practice writing out code. Okay, so until next time, happy coding. Hello, in this video we're going to take a look at another type called double. So you might wonder what you're supposed to do if you have a floating point value. So instead of having 7 or 5 or 1329 or whatever, you have something like, let's say, 8.3, something with a point in it. And for that, there's another type that you can use called double. In fact, there are at least 2 different types. Well, in a way, there are a number of different types you can use to do all of these things, but we're just covering some of the most basic, most common, most fundamental types here. And incidentally, before I get started, I just want to point something out, which I'm going to return to later, which is that if you have multiple projects like this, then you want to make sure that you're always running what you think you're running. It's a bit easy to get into the habit of clicking that run button and then running the wrong thing by accident. And to be sure, select the class, so app.java in this case, containing your main method before you hit the run button. And if you want to be absolutely sure, select it, right-click it, go to Run as Java Application, and then you absolutely know what you're running. Otherwise, you can get quite confused quite easily. Also, by the way, you can not only can you sort of contract projects like this, but you can right-click them and close them like this. Go to Close Project, and then you can open them again later when you want to. We're going to look at this stuff more later on anyway. I just wanted to mention that. Okay, so doubles. If you want a floating point value, you can't use the type int. So I can't write int, what should we have here? Maybe height equals 1.8. So that's not going to work. We get an error here. And if I hover over the error, it says type mismatch, cannot convert from double to int. So this is what we call a literal value here. It's we can also say that it's hard coded. It's a value that I've actually coded into my computer program, a literal hard coded value. And intrinsically, by default, it has the double type because it's got a point in it. We need to use the double type to store it. Incidentally, in the USA and the UK and some other places, we use a point. So we say 1.8, that sort of thing, to indicate fractional values like 0.8. Large parts of Europe apparently use a comma. But we don't do that in Java. As far as I know, all versions of Java are the same. We use a point to indicate a fractional value. Okay, so let's write here double. Now we've got something that will actually work. Now we've just got a warning, which is saying that we're not using it. And we can output that out just as we did with integers. So let's say height is plus height. And let's try running that. There we go, height is 1.8. We're going to start doing some stuff with this, but I'm going to leave it there for this tutorial. Try that out. Check you can declare double values. You can always put more of them in the same program as long as you give them different names, but do have a go at it. And we're going to look later on also at some general tips that you should use when programming and some tips for following this course. But at the moment, I'm just concentrating on getting you started with the most important things. Okay, so until next time, happy coding. Hello, in this video, we're going to take a look at arithmetic in Java. So we're gradually beginning to get towards writing something that really looks like a computer program and might actually be useful. So let's delete this. This is a copy of the program I was working on in the last video. And we've got, in arithmetic, obviously we've got, 4 operators that are very commonly used. We've got we've got plus operator. These are called binary operators because they work on two values together. You know, like 3 plus 4, there's two values, so it's a binary operator. And the general name for these things is they're called operators. We've also got divide, and in Java, the symbol for divide is a slash, like that. You have to get the right kind of slash. If you're going from left to right, you'd have to go up a hill. If you imagine sort of, I'm gesturing with my fingers, which of course you can't see, but it's like a hill sloping upwards from left to right. We've also got multiply, and in Java that's an asterisk. And in fact, these conventions are common in very many programming languages. And we have subtract, which is the normal sign you'd expect. It's a short dash like that. Let's try these out a little bit. So we'll have some variables. In fact, you can just use sysouts. Maybe we should also just do that to start with. And then we'll take a bit more of an extended look at this in the next video, I think. So if I write system.out.print line 7 plus 3, we expect to see 10. And of course we do see 10. There we go. We'll try some other things. We'll try all of them. If we try 9 divided by 3, we should see 3. So we try this. So it says 3. Here's a surprise. If we do, let's say, 10 divided by 3, we run this, we still get 3. Why is that? Well, if you divide one integer by another integer, the remainder will be discarded. So you won't get back a floating point value. You'll still get back an integer value. So for example, 5 divided by 2 would be 2 because we're just discarding the remainder of 1. If you divide an integer by an integer, then the result will also be an integer. But you can use floating point values. So if I divide 10.0 by, let's say 3.0, then we'll get the answer that you might expect, 3.333 recurring. So you can see that with floating point values it works. And you get a floating point answer even if only one of your values is floating point. So for example, if we divide, let's say, let's try dividing 9 by 4.0. Let's try that. So if we do that, we should get, we get 2.25, 2.25. So that works because one of the values is floating point. One floating point value gives floating point result. Now what I've just done, what I'm actually doing here, which actually I should have mentioned, and I think I've maybe touched on it briefly, I have, but if you write 2 forward slashes like this, everything else that you write on that line is a comment. It's very useful to write comments in your code, but it's better to use them to describe kind of what you're intending to do overall, or what you've done overall. There's not much point putting a comment saying output 10 divided by 3, because you should learn to understand that just from seeing this code. And also, if you write a comment and then you change the code and you don't change the comment, you can seriously mislead yourself. So comments are important, but generally better saved for blocks of code where otherwise it wouldn't be clear what the intention of it is, for that sort of thing. We'll take another look at this in a video shortly, actually. Okay, let's carry on with this. So if I write sysout, let's try. So we've got Plus we've got divide, let's try multiply. So 3 times 4, we expect that to be 12. There we go, it works. And of course subtraction. So let's do 3 minus 4, because that should give us -1. And if we actually run this, we see that indeed we get -1. So try all of those out for yourself and put some comments in as well, just to kind of describe what you're doing. Although they may be a bit overly precise, unnecessary at the moment, it's good to get into the habit of using comments a little bit. Try them all out, and don't forget to try integer division like this one, and assure yourself that it discards the remainder. It doesn't work quite as you might otherwise expect. Okay, and try floating point division as well. You can try all of these with floating point and integers if you can be bothered. Okay, so until next time, happy coding. Hello, in this tutorial we're going to look at assigning values to variables. So I've written a comment here actually, and it's a multi-line comment. So if you want to have one line of comments like this, that's just text on one line, the next line wouldn't be a comment anymore. And that starts with 2 slashes, but you can also have multi-line comments with /*, and they end in */. These stars are just decorative. We don't actually need them. They just look nice, but that's why Eclipse put them in. But this video is about assigning variables. So if you want to have comments on multiple lines, you can just enclose them with /* and finish them with */. Okay, so let's declare some variables here. I'm going to have int dogs equals 8 and int cats equals 3, and we can output those values. So we can say dogs is that, and the number of cats, we're going to have cats. And if we run that, we should see what we expect. Let's check. So yes, it says down here, dogs 8, cats 3. Okay. Now we can change variables as we go along. So underneath this, so underneath the system.out.print lines, underneath those, let's set the number of dogs equal to the number of cats. So I'm going to do that by saying dogs equals cats. And we'll output them again. Let's try this and see what it does. So if I run this now, we see that the number of dogs has been set to what the number of cats was set to, which is 3. This can be very confusing for beginners. So to start with, we have 8 stored in the variable dogs, and we have 3, I should say, I'll use the proper language, I've got 3 assigned to the variable cats. And later on, we say, this is saying here, take whatever number is in cats and assign that value to the variable called dogs, and then we display them again. Remember, your program's working downwards, so it does this, then we output those values, and then we're changing the value in dogs, and then we're outputting the values again. This looks perhaps confusing because it reminds people of an equation. For one thing, it looks as though we're saying the number of dogs and the number of cats is the same, but that's not what we're doing here. This is assigning a value to the dogs variable. When we write a variable and we write equals and then some value, we assign a value to the variable. We're actually changing the value in this dogs variable using this assignment operator. Technically, it's not an equality operator, it's an assignment operator here, this equals. And the value that we're giving dogs is whatever value cats has, and that's 3, because we assign the value 3 to it. So we end up with cats is unchanged, it's still 3, and the number of dogs is 8 by the time we run the program. Let's try this again. So there we go, they're both 3. Now, these variables don't know about each other. They don't. It's not like the number of dogs is forever linked to the number of cats. So if I write here cats equals 10, what have I done now? Well, the value of cats was 3. I set the number of dogs to the number of cats. I set it to 3. Then I changed the number of cats to 10. The number of dogs is still 3. So we should have dogs equals 3 and cats equals 10. Let's run this. And that's what we've got. Dogs 3 and cats 10. Often I want to output the values of variables multiple times as I go through my program. For example, when I'm debugging, and I like to just put numbers on those. So here I could say 1, and this is 1, and let's say this is 2, and this is 2. Makes it just a little bit clearer, I think, what's going on. So it looks like this. Try that out for yourself. So declare some variables. You can have 2, 3, however many you like. Display them, try assigning new values to them, and try assigning the value in one variable to another and display them again. And if you like, you can carry on, change the values again, output the values again in your console. It's really worth doing this. So you may be watching thinking that you can just memorize this, and you can up to a point, but you'll quickly lose the thread of what's happening if you don't practice. It's very important to practice this. Try it out practically. The more you do that, the better. Okay, so have a go at this yourself. Try declaring variables, outputting them, changing the values, outputting them again, and I'll catch you in the next video. Until then, happy coding. Hello, in this video we're going to take a look at doing calculations. So let's say I've got some people and their average height is 1.67 meters. So double height equals 1.67. Now let's say I want to know, I've got 7 of these people and they're performing acrobats, and they're going to all stand on each other's shoulders. And I want to know how high 7 of them will be standing on each other's shoulders. So I could just write sysout height times 7. Or if I like, I could write 7.0. Here it makes no difference. And if I run that, I find that the answer is 7 of them on top of each other are going to be 11.69 meters high. Now, what I could also do is I could write double, let's say, result equals height times 7. And then I could output the result. Let's run this and we should get the same result. Okay. Now, there is one thing that beginners often tend to do, which is a bad idea, which is that beginners are liable to give variable names really short letters like R. Occasionally that's appropriate, typically when you're using mathematical equations and the convention is that you would use, for example, an X or a Y, then it makes sense to just use one letter. But most of the time, don't give variables one-letter names because it gets very confusing. Another thing is, in general, don't give variables vague names. So here I've written result. What does that mean? It really tells me nothing about what I'm actually doing here. So it would be better to give it a more specific name. Give it the most meaningful name that you can. You can also even use multiple words in your variables. So I could create a variable called total height. And what I do is, by convention, in the convention that Java usually uses, the first word in your variable has a lowercase first letter. So the variable starts with a lowercase first letter, but any word after that has an uppercase first letter. So total height will be written like this. That makes it easy to read, and it's also meaningful. So if you don't know exactly what you're calculating, you're just kind of making something up to see how it goes, then it might make sense to write result here. But if you possibly can, give your variable a meaningful name. It's better to make it excessively long than to make it excessively cryptic by making it too short and too meaningless. It makes your programs a lot easier to read. Okay, so we're here creating the total height of 7 people stood on top of each other. Now, supposing they also have a flagpole, the height of the flagpole I'll define in another variable. So like this, double flagpole height, let's call it, equals, let's say the flagpole is 2 meters high. I'll write 2.0. And in fact, this height here, well, that's not very meaningful because now I've got multiple heights in my program. I want to change it so that we have this height and this height. Wherever I've used height, I want it to say person height. Rather than do that by hand, since I've got multiple versions of it, I'm going to right click and I'm going to go to source, and I'll go to, I'm going to go to refactor. So right click it, go to refactor, rename, and type a new name. So I'm going to type here person height, and it corrects all of my variables that are called height. It corrects the specific variable that I want to change. Okay, so we've got the height of a person, we've got a flagpole height, we're calculating the total height of 7 people on top of each other, and I also want to add the height of the flagpole on top, because I want to know how high the whole thing is. 7 people on top of each other, and the top one is waving a flagpole, holding it presumably by the very end of it, using his or her fingertips. Let's run this. I've got to save it first. And so this is what we originally have at 11.69. So if I add the flagpole height, we should get 13.69. Let's add that in. Plus flagpole. And to save me typing out the variable, I can hold down Control and press space. And then it brings up a list of suggestions, and I can hit return to select the first one. Okay, let's run this. And now we get 13.69. One last thing I want to bring to your attention is that this looks ambiguous, this expression, because does it mean person height times 7 and then add the flagpole height, or does it mean person height times 7 plus the flagpole height? So you could add 7 to the flagpole height and then multiply the person height by that. Or you could add 7 to person height and then add the flagpole height. There are rules called operator precedence rules, which we're going to talk about a bit. But for now, when you have an expression like this, and this is really good practice anyway, put round brackets in to make it less ambiguous. So if I put round brackets around this part, that makes it clear that I'm multiplying the person height by 7, and after that I'm adding the flagpole height. Hopefully you understand what I mean, because the other thing that we could have done instead is I could add 7 to the flagpole height and multiply the person height by that, but that gives us something else. It's not what we want in this case. Here we get 15.03. But what I want is to add the person height, multiply it by 7 and then add the flagpole height. Let's run this. Okay, soon I'm going to give you an exercise with this, but there was a lot in that video. So what I would recommend is that type this out yourself and run it and get it working, and then make up your own little program. Think of something you could calculate, no matter how silly. We're not standing on pride here. It's good to experiment with silly ideas. Think of something you could calculate and try to calculate it. And let's put a comment in here with 2 slashes, and I'm going to write calculate height of 7 people plus a flagpole. There we go. Okay, try that for yourself and then try to make up a little program that does a calculation and see how you get on. And until next time, happy coding. Hello, in this video I'm going to give you some tips about programming in general. I'm going to give you an exercise soon, and in the next video actually we're probably going to look at some tips about how to get the most out of the course. But in this video, firstly, before all that, I'm going to just talk about programming in general a little bit. So I've got some tips here. We're going to look at these. So my first tip for programming, and these really will help you a lot. This is not just idle chatter. These will help you a lot if you do them. So strive for great formatting and use auto format. So what you should do is when you're developing your code, let's open this. So when you're writing code, run the auto formatter regularly. So remember that's Command Shift F on the Mac, it's Control Shift F on Windows, and you can alternately, although it takes longer, you can right click the file that you want to format and go to Source Format. All right, so run that all the time, run this auto format, because it's really important for the sake of understandability, readability, to keep your code well formatted. But equally, strive to write your code in a way that's well formatted to start with. And you'll know you've got it right because when you run the auto formatter, it won't change your code formatting. The auto formatter will be happy with what you've already written. So try to write your code so that it's formatted well in the first place. And if you get that right, when you run the auto formatter, it won't actually change your code. But keep running the auto formatter, keep doing that. Try to get to a point where it doesn't have to do any work. That will really help you. If you can learn good formatting, you've avoided one of the worst beginner's mistakes that causes so many problems. Bad formatting really wastes a lot of time for beginners. So if you can get it right, start getting it right to start with, then that will give you a big sort of helping hand. Google error messages. So if you make a mistake in your code, let's miss off a semicolon here. You'll get an error icon here, and also if you try to run it, let's save it and run it, you'll get an error down here in the console, unresolved compilation program. Syntax error, insert semicolon to complete statement at line 8. I can even click on this line and it takes me to the right line. Now here it's pretty obvious probably what the message means. Well, relatively obvious. It could still catch you out if you're a beginner. It's telling us to put a semicolon at the end of the line. But often you'll get error messages that are quite cryptic and you don't understand them. Type those error messages into Google or the search engine of your choice. And maybe add Java as well. And then you'll often see web pages that will be very helpful. They'll explain to you what mistake you've made. And that's a lot quicker than having to, you can ask questions in the course, but it's a lot faster if you can just get to the bottom of it yourself with a web search. So literally, whatever the error message says when you hover over the red icon or when you run your program, don't be afraid to type that into a search engine and see what comes up. You might need to add Java as well to get the right results, and that will usually help you. It will help you to figure out what's actually gone wrong. Output values of variables. So when you're working through your program, let's take a look at this one here, I think. Put in system.out.println and output the values of variables and put those in your code wherever you're not sure what the value of a variable is. So at this point, for example, I might be going to write more code further down that depends on total height. And I might want to check that this total height calculation actually works. So at that point, I can output the value of this variable total height and check that it is what I expect it to be. And that's something that all the programmers that I know pretty much use that all the time. They put system.out.println in their code to check that variables have the values they expect them to be at that point in the program. So you can output the same variable multiple times as you work down through more and more lines to check that at any point in your program it has the correct value. That's a really useful tip. You'll see me doing that as we go through the course. Write code a little bit at a time, running frequently. So don't write a whole page of code, like a big page bigger than this. Don't write a big chunk of code and without running it. So write your code in little bits and then output the values of important variables or just all your variables or whatever you like. And then run it, check that works, and then you can delete the system.out.print line if you don't need it, and then add more code to it. So what I'm saying is, don't write a big piece of code and only then run it. Write code a little bit at a time, add code to your programs a little bit at a time, and after you've written a new bit, output the values of some variables so you can check that they are what you expect and run the program. So build up your program a little bit at a time. That will really help you. And you'll also see me doing this in this course, I think. Write the end of a pair of brackets or quotes before filling them in. This will make more sense to you later on. But if you've got something that comes in pairs in your program, like brackets are usually in pairs. So this is a pair of brackets here. That bracket is paired with that bracket. This square bracket is paired with that square bracket. And also this speech mark and this, they're a pair as well. So in general, I recommend when you write some opening pair of something, write the closing pair at the same time, then go in and fill in whatever's in the middle of them. You can do that with quotes and brackets. The point is to avoid situations where you've written an opening quote or an opening bracket and forgotten the closing one. So you might want to come back to this video later on because this will make more sense to you later on. But keep everything in pairs, write the closing one soon after you've written the opening one. And finally, make sure you know what you're running, because as a beginner, I often got confused. I'd have multiple projects open. I'd click a run button in my IDE and I'd run the wrong code. And then I'd be changing the code and I'd be looking at the output in the console and thinking, why aren't my changes having any effect? And it's simply that you're running the wrong program. So I might be working on this program here, but I click the run button and it doesn't run that code. So make sure you run the right thing. And to be doubly sure, so it helps to have the right code selected, or the right project at least. I think that will probably, that changes what you're actually running. But if you want to be absolutely sure that you're running the right thing, select the file that has your main method in it, right-click it, and go to source. No, sorry, where are we? Go to Run as Java Application. So I select something that I want to run. I right-click it and I go to source. I go to Run as Java Application. And after that, you can just use the run button. But it helps if the first time you run something, if you're not completely sure you're running the right thing, actually select it, right-click it, and go to Run as Java Application. And that will help a lot, because if you've got multiple projects open, it's really easy to get confused about what you're running versus what you're writing at the time. That's it for this video. You might want to come back to this later if you start finding programs getting really confusing, but I wanted to just run these tips past you to start with. Okay, so until next time, happy coding. Hello, before we go on to look at some worked examples of what we've seen so far, I've got just a few more tips for you, and most of them relate to the course specifically. First of all, the source code. If you go to github.com/caveofprogramming, this is where I keep my public source code. So you can look at this, look at whatever you want, but if you click on repositories and then go to find Java Beginners 11 in the list, click on that, you can find here all the source code that we're working on. So if I want to see this source code, I can actually browse it and see it here, which is helpful. I noticed that when I provide these repositories, some people want to download the whole thing and then build all the applications. I would recommend not doing that. You can do it if you want to, But I would recommend not downloading it because you don't learn anything like that, really. What this is best used for is just consulting it if you've got something wrong somewhere and you can't figure out what it is. Of course, you can look back at the video, but it's probably easier to look at this source code in many cases. So take a look at that, and if you keep it open while you work, then you can refer back to it. Okay, so a second thing that I'm going to say here is to get the most out of the course, always type out code and experiment with it. So you can't learn programming just by watching videos. It's like learning the piano or the violin or learning a human language for that matter. If you just watch videos, you aren't going to learn it. What you have to do is use the videos as a source of inspiration and information. Type any code that I type in the videos. Make sure at some point you type it out yourself. And even better, try to think, how could you change that code without breaking the program? Try to make some meaningful change to it. Experiment with it. And the more you do that, the more you'll learn. You will find sometimes you'll create bugs and errors. Maybe you won't be able to fix them. But if you spend some time trying to figure out why your program doesn't work, even if you never actually figure out why that is at this stage, all the time you spend doing that, puzzling over it, will really help, especially if rather than just looking at it, you also experiment with it. Try outputting the values of variables. Try to experiment with it kind of physically, change the code, try to get it to work and to run. But the main thing here is type everything out and also experiment with it a little bit. Try to change it and still have it run in a meaningful way and do something useful. Because you won't learn just by watching videos. It's a practical skill like learning the piano. Let's take a look at this one. So I would say focus on practice, not memorization or notes. And the reason that I say this is because I've seen beginners try to learn programming by, like, they have a lesson or they watch some videos and they make endless notes on it, or they really strain their brains trying to memorize everything. And I would say that's not an effective way to learn. The effective way to learn is to practice. Think of it just like learning the guitar or whatever. You've got to practice. Practice is the key to it. So don't worry too much about memorizing things. Don't worry too much about making notes, but practice everything. So everything that you want to learn, you have to actually try it out yourself, check that it works, experiment with it a little bit. If you do that enough, you will learn programming bit by bit. You may sometimes feel very puzzled, but eventually you'll get the hang of it. And it's really a question of how much time you spend doing that. You have to practice. And a lot of practice is going to be needed. But the good news is that after a certain point, programming tends to be addictive. People tend to get addicted to it and time flies by. Not everyone has that experience, but many people do. That you start writing programs, and when you reach a certain level of fluency, you get into this state of mind where you're just curious and you think, well, I could add this new feature to this program, see if that works. And it becomes an addictive process for many people. And that can really help with the practice. If you're addicted to something, of course, you'll practice it a lot. Don't forget to go outside though, and take breaks. Don't screw yourself up with programming, but practice is the key. And finally, this is optional. Learn to touch type. Touch typing means being able to type on your keyboard without looking at the keyboard. Now, I think only about half of all programmers, for a guess, have this skill, and the others do what we call hunting and pecking. They hunt and peck. So they keep looking down at their keyboard. They use 1, 2, 3, however many fingers, and they just type the characters one by one. That's fine. It's totally fine. But if you want to learn even faster, then learn to touch type. You can find free touch typing programs on the internet. If I search for free touch typing, you can find various links here to programs online that you use on the internet that teach you to touch type. And it's actually not that hard to learn to touch type. Probably most people can do it in a few weeks or less, especially if you start touch typing your emails, it's difficult at first to make the transition from hunting and pecking to touch typing, but you can learn this quite quickly. And when you've learnt it, your typing speed will increase a lot. Now, although typing speed isn't a big deal in programming, you can type slowly, and you're still gonna be writing programs. Programming is not primarily about typing speed; it's not so important. But a major reason that people get discouraged with programming is they just feel it's taking them too long and too much effort to write code, so they avoid writing code. And you can learn a lot more effectively if you touch type for this reason, in my opinion. You can learn faster because you're less discouraged from writing code. You don't think, well, how long will it take me to type out total height, or how long? You don't think like that. Instead, you think and your fingers do the typing, more or less. So touch typing can help make you less reluctant to type code, and by doing that, it makes it easier to learn coding. Nevertheless, that is optional, and probably half of all programmers, something like that, they just hunt and peck. They don't learn touch typing, so it's up to you. Okay, so until next time, happy coding. Hello, in this video we're going to take a look at a worked example of converting temperature in Celsius to Fahrenheit. So generally these days in the UK we use Celsius to measure temperature. So we consider room temperature to be about 21, whereas in the USA, as far as I know, Fahrenheit is used. And well, what we're going to do is convert Fahrenheit to Celsius. So I would suggest pausing the video at this point and having a go at it yourself. If you go to Google and you type something like convert Fahrenheit to Celsius, then you can find a formula for how to do it. So what this is telling us is that you take the temperature in Fahrenheit, subtract 32 from it, then you've got to take that and multiply it by 5 divided by 9. But don't forget that you can't divide one integer by another in Java, or rather you can, but it discards the remainder, so you want to use doubles there. Okay, so pause the video and have a go at that yourself. If you find yourself sort of struggling a bit, that's actually good. It's great if you can just write the program, but if it takes you a little while and you have to think about it, that's good, because all the while you're looking at this program and typing stuff and trying to get it to work, you're learning. So, okay, pause the video now. All right, so hopefully you had a go at that. Let's see how to do this. So I'll zoom out here, and then here, the first thing to do is we'll declare our temperature in Fahrenheit, so double Fahrenheit. And let's set it to some temperature to start with. So let's say we want to convert 91 Fahrenheit to a temperature in Celsius. I don't know what that is. I have a feeling it's quite hot. We'll see. Let's also have a variable for storing Celsius. So let's say double Celsius. And what's Celsius going to be assigned? What value will we assign it? Well, we're going to take the temperature in Fahrenheit and we're going to subtract 32 from it. Now, in order to make sure that we do the calculations in the right order here, let's put that in round brackets, because that's the first thing we want to do. We want to take temperature in Fahrenheit, subtract 32, and then we're going to work with that. The next thing we want to do is we want to multiply that by 5 divided by 9. So let's do that. Let's multiply it. So that's an asterisk by, and we can't say 5 divided by 9. That would be integer division. It would discard the remainder. So in this case, that will give us 0. But we can say 5.0 divided by 9, or we can also say 5.0 divided by 9.0, or 5 divided by 9.0. As long as there's a double in there, we get double division. That should do the trick. So now we can type sys out, and let's write temperature Well, actually, let's write the whole thing out. Let's say Fahrenheit, and I'm going to add to that some text, concatenate some text. Fahrenheit, let's say, so this is going to say that's going to say so far, like, for example, 91. So let's say 91 degrees Fahrenheit. I think that should have a capital F, not on the variables because they have to have a lowercase first letter. So 91 degrees Fahrenheit is plus Celsius plus degrees Celsius. Let's run that. I think I had the street cleaner running past, so sorry about the noise. We'll try running this. And there we've got 91 degrees Fahrenheit is 32.7778 degrees Celsius. So by British standards at least, that's very hot. A temperature we rarely encounter, in fact. So what have I done here? Well, you see that I've basically just joined numbers and text together. And when I join the text to the number, I started off, so inside the double quotes here, I started off with a space. And that gives us this nice space here. So after is, we've also got a space. And that's this space here. And so then we've got the temperature in Celsius, and we've got finally some more text to finish it off. And we've got a space there as well. So the whole thing comes out nicely spaced. One thing that isn't good is that we've got a lot of digits here. And we're going to look at how to deal with that in the next section when we take a look at strings and text. I don't think there's anything else to say about this. It should be fairly straightforward, but if you found it confusing, you couldn't do it, whatever, don't worry too much. But if you couldn't do the exercise, definitely type this out yourself and try playing around with it a bit, to see if you can change the formatting or whatever. If there's anything in it that bothers you, try to guess how it works and maybe make changes and see if your changes work as you expect. But definitely type it out, whatever you do, unless you successfully wrote the program. Okay, we'll leave it there for now, and until next time, happy coding. Hello, in this section of the course, we're going to take a bit of a look at strings, and then after that, we'll be able to get on to actually doing loops and things like that, so it will start to look more like a real computer program. Strings are used for dealing with text, basically. So the word string in programming lingo means some text. It's like a string of letters, you could say. Let me show you a slightly quicker way of creating a new project first. So I'm going to go to File, New Java Project. I'm going to fill in a name. Let's call it strings. And I'm just going to click Finish straight away. So the Java version is set to my default anyway, and that's what I want. Click Finish. Because we're using Java 11 here, it asks me if I want to create a module, and we're not going to use that for the moment, so I'll click Don't Create, and there we've got our project. So I can do the same as usual, right-click, go to New Class, call it App, put it in a package which I'll make up a name for. I'll call it Application, as usual, and tick to say that I want public static void main finish. Okay, so we just missed out one screen, but it's a slight time saver. So we've seen that you can write things like int cats equals 7, or we could write double height equals 5.3. So these are just variable names that we make up, and these are primitive data types, int and double, used for storing whole numbers and floating point numbers respectively. Both of them can store positive or negative values, and they both have a sort of minimum or maximum value that you can store using them. And you can find out what that is if you just search for Java primitive data types and look at that page. What if we want to use text? With text, we use a variable type called string, and this has a capital, has an uppercase first case, it has an uppercase first letter. Let's say string, and I'll call it name. So again, this is just the name of a variable. I'm just making it up. I'm calling it name. And I'm going to assign that the value John, because that's my name. So let's get rid of these. Why does string have an uppercase first letter here instead of lowercase? Well, the answer is string is not a primitive data type. It's actually a thing in Java that we call a class. And in that respect, it's similar to app. App is a class we're creating ourselves. String is a standard class that's part of the Java API, or application programming interface. It's part of Java, essentially. So string is a class, and it's a variable type here. So it's a type of variable, string. All right, so we can output that with sysout, system.out.println. Let's output name, and let's just run that. And it says John, as you might expect. There are lots of things that we can do with strings, and we'll start looking at those in the next video. Until next time, happy coding. Hello, in this video we're going to take a look at a few things you can do with strings in Java. So let's create a string for a start. Let's say string name equals John. And we've already seen that you can display this. So if I just type sysout name, we could display that string. We can also join strings together. So in sysout here, I could do this. My name is, let's put a space in and then a plus. So what's this actually doing? Well, here we've got a string variable, a variable of the string type, and we're assigning it this string value. So this text in quotes is called a string literal. It is a string itself, and that's why we can assign it to a variable of type string, which is effectively also a string. So this is a string, and this is a variable that's capable of referring to a string. Now, when we were looking at primitive variables, I said that a primitive variable is a bit like a bucket that you've put a label on and you put some value into that bucket. This isn't a primitive type of variable because string is not a primitive type. It's what we call a class in Java. So this works a little bit differently. This is a bit like, it's a bit like if you write down an address on a piece of paper. The address of a house. What is that thing that you've written? It's a kind of an instruction for where you can find a particular house. And with non-primitive variable types, that's similar to what you get. So by assigning a value to this name variable, it's as if we're telling name to remember where this string literal is. So this is what actually creates the string, and this assignment operation here is saying make name kind of store the location of this string so you can find it again. And there we're actually using it, and we're using name to refer to this existing string. Don't worry too much about that. It'll become clearer to you as we go through the course. What we're doing here is we're taking a string literal and we're joining it or concatenating it with another string. So when we run this program, it says, my name is John. We could also we could define a variable, declare a variable, I should say. I'm trying to use the exact right language here. We could declare a variable that refers to a string literal like this. So let's do that. Let's say string text, I'll just call it text. So I'm just making up names for my strings here, equals, let's do something a little bit different. I'm going to write I am called. All right. So I've declared this variable of type string, and I've assigned it the value of this string literal. So really I'm telling it to refer, I'm making it refer to this string literal here, which is just some text. It's a string. And let's do sysout like this. And then I'm going to write text plus name. So here I'm joining two strings together. Essentially, I'm joining this variable with this variable. So really what I'm doing is I'm joining this string literal with this string literal. Yeah, because I'm joining that with that. Okay, let's run this and we'll see that it works. I am called John. And you can join multiple strings together. For example, I could define another string here. Let's call it end of sentence. So here I've got a variable name that's made up of multiple words, and I'm following the convention as usual. The first letter is lowercase, and we uppercase the first letter of each subsequent word. I'm going to set that equal just simply to a full stop, like that. And then in my system.out.println, I can add on end of sentence. And here, to save me typing, I'm going to type the first bit and then press Control and then space. So Control and space at the same time, and hit return to select the first option. And it auto completes for me. Okay, let's run this. And you see that we've got a full stop on the end. So we've concatenated three strings together here. Try that for yourself. Try this little program and check you can get it working. And then try to make up some combination of strings and just output them yourself. So make up some program that involves, let's say, 3 strings and join them together and output them. Something like that. Make something up. Okay, so until next time, happy coding. Hello, in this video we're going to take a look at control characters in strings. So let's define a string. So I'm going to write here string, I'll call it text. I'm giving it a generic name because I don't really know what it's going to be exactly. But I'll write some text here. What should we write? To be or not to be? That is the question. All right, so we've got 2 sentences here, and we can output that, sysout, and output text. So let's run this, and we've got the output as we expect. Now, within strings, because they are simply just text, you can use more or less any character you want to use. Almost any character that you might feel like using is valid in there. It's just ordinary text. But we can put control characters in there. So all of the characters we've got in here are printing characters. Well, in a way, even the spaces. I'm not sure how it's classified, but the point is that they all visibly display in your output. So the letter B visibly displays as it is. The space, well, that just creates space. So I guess it's a non-printing character. Anyway, let's not worry about that. But the rest all visibly display. But there are non-printing characters, and these are things that alter the formatting of your string. So they don't actually display themselves. They alter the position of it somehow. And probably the most commonly used one is the new line character. So the non-printing characters or control characters start with a backslash. So \n means new line. So at the point where I have this, we're going to create a new line. In other words, we're going to see that these two sentences are now on two separate lines. And we don't want that space anymore because we don't want to start a new line with a space or whatever. Let's run this. And you can see we've got that on two separate lines now. Another really common character that you might want to use is tab. So let's indent the first line with a tab. So you can put it anywhere in your string, but we'll put it at the beginning here. Let's write /t. That gives us a tab character. So when we run this program, we can see that the first sentence has been indented by one tab. We'll put another one in because this looks ugly. Let's at least line them up. So directly after the new line, I'm going to write /t. So we've got a new line here, followed by a tab character. And if we run this, now they're both tabbed in, one tab. If you actually, for some reason, want a slash in your string, because slash normally starts a control character, you can't just write slash in there. It will think I mean \o. It will think that must be some weird control character, so we get an error. I don't think \o is a control character, or if it is, I haven't used it. But anyway, it's not valid to just put a slash in by itself. If you actually want a slash in there, you have to write two slashes, and then it works. So here we've got to be slash or not to be. Okay, anyway, let's get rid of that. That's not something you usually use because you don't normally need slashes in your string. Okay, now I'm going to give you a little challenge. Let's write this in a comment. So I'm going to put /*, it's a multi-line comment, and it ends in /*. And this star is purely decorative. It doesn't have to be there. It just makes it look nicer. So let's imagine that we want to output some text on the console that looks like this. So it's indented by, let's say, a tab, and it says select an option, : and then indented a little bit more underneath that, we're going to say what should we say? Add an entry to view the database, or 3, exit. So look at this bit of text. Forget about the asterisks. They're just there for decoration or because they're part of the comment. How would you output this text on the command line? So you've got 4 lines here, and 3 of them, the first one is indented 1 tab, and the others, let's say, they're going to be indented 2 tabs. So they're indented 1 tab relative to the first line. Have a go at that yourself. It's up to you how you do it, whether you store these lines just in one variable, which is easiest, or you put the numbers in there separately or whatever. I'll leave that up to you. If you want a particularly challenging task, store the numbers separately. So 1, 2, and 3, store those in integer type variables and store the rest in strings. Okay, have a go at that task. Try to write a program that outputs this on the command line. And if you can't do it, don't despair. We'll take a look at it in the next video. Hello, in this video we're going to work through a possible solution to the exercise I gave you in the last video. Do watch this video even if you successfully did the exercise, because I'm going to make a few remarks here. If you've managed to output this text by any means at all, then basically you've done the exercise and you've solved the problem. If you couldn't manage to do it, then maybe watch this video and try again. Try to get that working. You should be able to do this, especially you might need to watch the previous video again, but you should be able to manage it. Okay, so I'm going to store all the text here in strings. So the first one, let's call it prompt and set it equal to select an option. And then we'll have also a string option1 equals add an entry. Now you can use numbers in variable names, like I've used 1 here. You just can't put them at the start of a variable. So putting them at the start of the variable gives you an error, but you can use them at other positions in your variable. And we'll have 2 more of those, which I'll call option 2 and option 3. Option 2 is going to be view the database, and option 3 is going to be exit. We'll also have some numbers in here. We'll separate those out just to make it as complicated as possible. Let's call this value 1 and set it equal to 1. Notice that this is a number and we're assigning it to a variable of type int, which is an integer. If I had a 1 in double quotes like that, so this gives us an error because here would need type string, because this is text. So whatever you put in quotes, it doesn't matter even if it's digits and it looks like a number. It's not a number, it's some text. So stuff in quotes is treated as text, whereas this without the quotes is a number. And those things are different. Numbers and text are treated differently in Java. So it doesn't matter if you've got text that just looks like a number. It's not number. It's not a number here. It's text because it's in quotes. Anyway, we'll get rid of those and we'll copy this and we'll have another 2 of them. So value 1, 2, 3, 2, 3. So we could just output those. We could also store them in another string. Let's call it menu. So what do we have? We have prompt, and then we've got option, we've got value 1, and then we've got option 1. I could just type these out in a massive long line. I could add them all together, but I'm going to do something slightly different. Let's in fact start this off as just being an empty string. All right, and then we're going to say menu plus equals. What does plus equal do? Well, this is the same as writing menu equals menu plus this other stuff. So in the context of a string, what plus equals does is it takes the existing string, whatever's already in it, which here is nothing, and then it adds more stuff onto it. So by this means we can build up the menu without having a hugely long line. We're going to see another way of doing this later on, but for here let's carry on like this. In fact, let's set this initially equal to prompt, and then I can add on the values and the options. And what I'm striving for here is I'm striving for elegance. I'm trying to make this look beautiful because I want it to be clear and easy to read. I want it to be very logical so I can see what's happening here. The more beautiful your program is in general, the easier it is to modify it and remember what it's actually doing and that sort of thing. Let's try outputting that. So at each stage, I'm using plus equals to add more text to the existing string. It starts off as prompt, and then it's prompt plus 1, add an entry. Yeah, there we go. Then it's we take that string and we do plus equals and then join this on. So we're using plus equals to keep adding more text to the menu. So if we output that, what's it look like? Terrible, because it's all on one line. There's no tabs or anything. Let's add in some tabs. So to do that, we could just put them literally in here. That would work, or here. Let's try it. So here I'm going to put it in double quotes, /t plus. Do I need anything else? I don't think I do at that point. So the others are going to start with 2 /t's. So I'm going to have /t plus, and we also actually want a dot and a space after the option. So I need to add that in as well. So let's put that here, dot space plus. Okay, so it looks like this. Let's go through and add all of these in. So I'm going to copy that and paste it. I'm trying to use as few keystrokes as possible as well, because it saves typing. Let's run that. And still not working because we need the new line. It looks better though. So let's add in some new lines. Let's say here +/n. Need double quotes there. All right, and I need to add these to the end of every line. So now I run this and I've got my menu here. Okay, so now this is really a horrible program. I would never normally write a program like that. It's the best we can do if we, on the one hand, divide everything up, putting everything into separate variables, but on the other hand, we stick to things that we've seen so far. We don't use programming constructs that we haven't seen yet. But with some more knowledge, we could reduce this down to a much smaller program, and at the very least, a more elegant program that doesn't have all this repetition in it. There's a lot of repetition in here, which we could eliminate, and we're going to see how to do that in a future tutorial. So if you did something that output this text correctly, give yourself a pat on the back. If you did something horrendously complex like this, then that's amazing. That's really wonderful. If you didn't, then I'd suggest typing this out. Try typing it out for yourself to see what it does. You can even output the menu like here before you've completed making it, so you can see what that does. So if I run this, so now I should have two menus. So I've got this menu fragment at this point, and then I carried on adding two more options to it, and I create this second menu, which I output here. Okay, so try typing this out, if you can be bothered at least. I know it's a bit verbose, and see what it does. Maybe experiment with it. Check that you understand this. Check you understand the idea of adding more text onto an existing string. Okay, so we're going to go on to look at some things that would make this a lot more elegant and have a lot less duplication in it, but we'll leave it there for the moment. So until next time, happy coding. Hello, in this video we're going to continue looking at format specifiers, and I'll show you an answer to the last exercise that we looked at. So the exercise was to change this to have nicer output. So we don't want it to say 32.777, we want maybe 1 or 2 decimal places there. Let's maybe get rid of this, because I don't think we're going to need it. These are some examples from the last video of using printf and format specifiers. So to change this so that it outputs Celsius to 2 decimal places, the first step is to change this to printf. Now, if you tried to do the exercise from the last video and you couldn't do it, feel free to pause this video at any moment and then try to do it when you feel you've got enough hints of how to do it. Okay, so I'm changing this to printf, and then because I want a new line at the end, I'm going to put a \n in it, although that doesn't make any visible difference here because I've only got one line being output. So if I change this to printf, you can't tell that there's no new line at the end of it because there's only one line anyway. But let's put that in case we output more lines. So I'm going to put \n at the end there, and that doesn't look any different so far. Okay, so instead of putting Celsius here, instead of concatenating it into the string, I'm going to just have one string, and I'm going to put %f in it. And then this is one complete argument to printf. It's one single string because I'm concatenating this string, this double value, it's double value. I'm concatenating that with this string to make one single string. So now I'm going to put a comma in, and I'm going to supply a second argument. The second argument is going to be the value in Celsius, converted value. So that's going to be substituted into this %f here. Let's run it. Okay, so now it looks how it did originally, but the value of doing this is that we can now specify how many decimal places we want. So we can say %, let's say 0.1, I'll just have one decimal place, %.1f. And if we run that now, it looks a lot nicer. In fact, it looks like it's even rounded up the value to 32.8, which is great. I could also do that with Fahrenheit, so I could get rid of this concatenation here. And here I could, at the start, I could put %, let's say 0.1 again, %.1f. So now the first format specifier is the value in Fahrenheit. So that's going to be my first argument after this argument. So the second argument, I'm going to write Fahrenheit. And then the third argument is Celsius, and it's going to replace this. So that they're replacing these arguments here, second and third arguments to this printf method, are replacing the format specifiers in order. So first one is Fahrenheit, second one is Celsius. Okay, let's run that. And well, it looks great. 91.0 degrees Fahrenheit is 32.8 degrees Celsius. Hopefully that's correct. I'm just wondering whether I should put anything else in this video. There are other things I can tell you here. We'll perhaps leave it there for this video. Try that out yourself and get it working and see how it looks. Okay, so until next time, happy coding. Hello, in this video we're going to take a look at getting input from the user. So we're going to take an important step and actually make our program interactive. So to do that, I'm going to use a class called Scanner. So at the moment you still don't really know what a class is, but we do have at least one, well, we have a couple of examples of classes here. We've got app, and that's a class that we're creating ourselves. We've said here public class app, we've created an app. And we've also got a system here, and we can recognize these because they have uppercase first letters. These are actually classes, and you'll find out what a class is later on. We're going to use another class in this video called Scanner. So I'm going to write something that's going to look quite cryptic, but if you type it out a few times, you'll get used to using it, and you'll gradually come to understand it as you go through the course, as with many other things. So after the opening curly bracket of this main method, I'm going to put a couple of blank lines, and I'm going to write scanner with an uppercase S, scanner with a lowercase s, equals new scanner, 2 round brackets and a semicolon. It's the capitalization is very important here. You have to get it right. And between these 2 round brackets, I'm going to type system, capital S, .in. And we've still got an error at the moment. Now that's because I'm using this scanner class, which is part of Java. It's part of the JDK, Java Development Kit, but it's in a package, and my program doesn't know how to find this package. So to tell it where to find scanner, I'm going to use a shortcut key. So on the Mac, I'm going to do Command-Shift-O, or on the Windows, Control-Shift-O. I hold down, if I was on Windows, I'd hold down Control and press Shift. On Mac, Command and Shift, and then press O, the letter O. O stands for Organize Imports, and it brings up this dialog box. And I'm going to select this java.util.scanner and click Finish. And what that does is, all it does is it adds this line at the top of my program. After the package statement, it adds import java.util.scanner. And that's saying, when we say scanner in the program, we mean this scanner, and we're going to use this scanner, and it's in the java.util package. So this, what a package is and a class will become clearer to you in time. For the moment, I'm just kind of trying to get used to the terminology. Let's take a closer look at this line. Looks a bit cryptic. Scanner here is a class, and we can recognize it because it has an uppercase first letter, an S. So let me give you a little question here. We're already working with two other classes in this one program, and maybe try to pause the video if you feel like it and see if you can figure out where those two other classes are that we're using on the basis of what I've just said. Okay, so now maybe you found them, or maybe you don't want to pause the video, but I'm going to tell you. So we're defining a class of our own here called app, and that's got a uppercase first letter. And we're also using the system class here. And we're using the system class here. It's the same class. So there's two that I can see already here. This here is a variable. It's a variable of type scanner. Now, I've also called it scanner. I've given it the same name as the scanner class, but with a lowercase first letter. Some people don't like to do that. They may even argue that this is bad practice to give a variable the same name as its type. So both are called scanner in this case. I'm a fan of it. I think it makes it clearer what this actually is. And I don't mind that they only differ by capitalization. But if you want, you can call it something different, like, scan input, or some people even call it input. But I find that a bit confusing here because it's not actually input. It's a thing that's used for getting input. And what we do then is we want to set it to a new, we call this an object, but we're setting it to a new instance of scanner. So a class is kind of like a template, and an object is like a particular object made from that template. So we're creating a new scanner object here, and that will become clearer also later on. Don't worry about it now, but it's as if scanner is a blueprint or a recipe for making something, maybe more like a blueprint. And here we're actually creating a particular instance of that thing. Like if we had plans for making a car here in the form of a class, and we have a particular car, we create a particular actual car by doing new here. And then we're saying that scanner is going to scan the system input, system.in, and that's going to be input from the console. Okay, let's actually make this work. So what we have to do is, I'm going to say, underneath this, I'm going to say, let's maybe have another blank line and write sysout, enter value in Fahrenheit to convert. And let's put like one of these characters, a sort of angle bracket pointing to the right to make it a bit more like a prompt. Maybe I'll have a space there as well, and I'll also change this from print line to just print. So hopefully the user can type directly after this space. We'll see how this works. So if I run this now, it simply outputs some text. And in fact, the result is on the same line, so it even looks a bit ugly. But after this, immediately after the system.out.print, I'm going to write, let's change this double Fahrenheit. So I'll move it up slightly. And instead of saying equals 91, I'll say equals scanner.next float. And as soon as I see the right thing selected in this autocomplete, I think I press Control Space sort of instinctively. So you type a few characters, press Control Space, and this thing comes up. S gets rid of it. So what I want is next float, hit return, and semicolon. Let's try that. So I'm going to run it. And in the console, it says enter value in Fahrenheit to convert. I'm going to convert 97, very hot. Hit return. And we get 97.0 degrees Fahrenheit is 36.1 degrees Celsius. What happens if you enter something that isn't a floating point value? Let's run it. Well, it's fine with integers. If I write 54 or something, it works. It can easily convert an int to a float, just treat it like a float. But supposing we run it and I enter something that's not even a number, like some random text, we get an error. And in the next video, we're going to look a little bit at that error. So for now, try this out for yourself. And if you're feeling creative, even better, make up your own program. For example, make up a program to convert miles to kilometers, something like that. You can find a formula for it here. To convert miles to kilometers, you just multiply the number of miles by 1.609. So you could write a program that asks the user for a number of miles and converts it to a number of kilometers, and it will work very much like this. Maybe have a go at that and type this out for yourself, I would suggest first, or just launch into trying to create a program very similar to this one that converts something to something else, but also gets input from the user. Okay, I'll leave it there for this video. Until next time, happy coding. Hello, in this video we're just going to take a little bit of a look at the error message that we produced in the last video. So hopefully by now you've at the very least typed out this code yourself, and I would strongly suggest at the very least experimenting with this, see what you can change, to make it do something slightly different, see if it works as you expect. And ideally you've written some program that gets user input and converts one number in one unit of measurement to some other number in some other unit of measurement. Or you've invented some exercise for yourself that's similar. Hopefully you've had a go at that, maybe converting miles to kilometers. And you shouldn't really encounter any great problems with that. Miles to kilometers would be basically the same program as far as I can see, except that we don't need to subtract anything. We'd just be multiplying it by something. I think it was 1.609. Okay, so I just want to show you this thing that's appeared in the console. If I run this and I enter something that isn't a number, hit return, then we get this error trace. This is actually called a stack trace. And the stack is basically how Java keeps track of one method calling another method. In other words, one method runs and it uses other methods, so other subroutines, and they sort of all make each other execute in a kind of a tree type thing, really. But let's not worry about that for the moment, because we're getting a bit ahead of ourselves, really. I just want to begin to familiarize you with this, because you're going to see a lot of these, and it looks very intimidating to start with. When you get errors in Java, they can look quite disturbing. So one thing to say is regarding this program, I don't think there's not really any way we can fix it at the moment using what we already know at this point, so that it can handle input that's not a number in a way that's more elegant. We totally can fix that, just not with what we know so far as I can see, or not easily. So we're not going to worry about it for the moment. We'll look at it later on, how we would fix this sort of thing. But when you see an error message like this, very often the first and the last lines are the most important. So if we look at the top, it tells us what the basic problem is. The problem is we've got a Java util.input mismatch exception. Now this is input mismatch exception is actually a class. And what we have here is, this is showing you that we say that an exception has been thrown, and we'll be looking at that later on. But you could guess from the name of it, input mismatch exception, that there's some sort of mismatch with the input that we've entered, which is of course the case. We entered letters when it was expecting a floating point number. The last line in this case actually gives us the error. It gives us the line and the file where the error occurred. So with really big stack traces, something that you can end up doing is sort of looking down them for the first line that it mentions that's actually in your own code that you've actually written. So you end up starting from the top and you're looking down it and you're looking at files that you haven't written yourself, and eventually you come to one that you have written yourself, and that's where you can start investigating the error. In this case, there's only one line referring to our own code, and it's right at the bottom, and it's here, app.java, line 13. So if I click on that, it will actually take me to the line. There we go, it's highlighted it, and that is where the error occurred. So we did scanner.next float, and that was expecting the user to input a float, but the user, me in this case, inputted some letters, so it threw a wobbly. It threw an exception, in fact, technically speaking. Wobbly is not a technical term. Okay, we've also got a warning here in this program, and if we click on it, it says resource leak, scanner is never closed. Now that's not a big problem, but we shouldn't leave warnings in our programs. What it means is, all it wants me to do is what I'm about to show you, which is this. Let's create a new line in our program. In fact, I can do this immediately after I've used the scanner, since I'm not going to use it again for anything. By this point in the program, line 14 here, I've just created a new blank line, of course, but I'm not using the scanner anymore. So I can write scanner.close. And then the warning goes away, and that makes it happy. So what scanner.close does precisely, I'm not completely sure, but I don't think it's important. It's not that important, but it will make the warning go away. So I advise you to do it. Closing things that we've opened in general is very important in programming. In this particular case, perhaps not so important, but in general, it's a good thing to do. And what we're closing, I suppose, is where we've got something that's scanning user input, trying to get user input and scanning it and trying to find out what's in it. That's what scanner does. In this case, it's scanning system.in, trying to get stuff from system.in, and it's trying to turn it, it's looking for a number in that user input, basically, and it didn't find one. And by closing it, I suppose we're closing, I guess, system.in, I'm not really sure, but it doesn't matter. Okay, so we know where the error is. We can't fix it at the moment. We know that if you enter letters instead of a number, it throws an exception, and we're going to be looking at exceptions later on. But for now, we'll just leave it as it is. Let's try it again now and check that it works. There we go, still working. Okay, so until next time, happy coding. Hello, we're going to finish this section by, I'm just going to show you some Eclipse tips and tricks, a few things you can do with Eclipse. So hopefully you've created that last program, you've got it all working, you put in the scanner.close, and or maybe you've created a similar program of your own. There are lots of other things that we can do with strings, and we're going to be seeing more of them in the course, but rather than overload you with a massive list of everything you can possibly do with a string, I'm going to introduce them more, try to introduce them more sort of organically as we go through the course. And what I'm going to show you in this video is just a few Eclipse tips and tricks. So one thing you can do in Eclipse is, I'm using the dark theme here, which in this version of Eclipse seemed to be the default, and I sort of decided just to go with it. But the default used to be the light theme, but you can switch between them and select which one you prefer. So if you go to Eclipse Preferences, so maybe that menu is different on Windows, I'm not completely sure, it might be in File or something. On the Mac I get a particular menu called Eclipse, but regardless, however you usually go to the preferences in programs in your operating system, go to that. You should be able to find these sort of Eclipse preferences somewhere. And in this dialog, if I type theme and just click appearance here, so I've got theming enabled and the dark theme is selected. If I want, I can select the light theme, and I'm going to click apply and close. Whoa. And then I'm going to restart Eclipse, because otherwise the sort of the change from one theme to another might not exactly be complete. So I'm going to restart it. So there are a few built-in themes, and you can find many more on the internet. So that's completely up to you. You can get Eclipse to look sort of more how you want it to look. Here we go. So it's very light now. I'll use this for the rest of this video, although it's hurting my eyes, because I want to show you some things that don't seem to work. One of them doesn't work too well in a dark theme. Something else I want to show you is working sets. So you see we've got a lot of programs open here, a lot of projects I should say. It's becoming a bit cluttered, and I can make that more manageable using working sets. So this worked fine in the dark theme when I tried it. But if you look at the Package Explorer on the left here, and if it's not showing, you can go to Windows, Show View, and Package Explorer. Sometimes, strangely, the console disappears, and you can make it reappear by going to Windows, Show View, Console. And if you manage to completely screw up your windows in Eclipse, you can go to Window, Perspective, Reset Perspective. Those are all good things to know. Actually, I should also mention that on the top right here, these are perspectives. So if I click this button, we can open other perspectives. And what a perspective is it's just a collection of windows that are geared to a particular task. Let's cancel that. And we are using the sort of Java development perspective, and that's what we want for the moment. So working sets, if I look at the Package Explorer, there's a little down arrow just there, View menu. If I click that, I can go to Select Working Set, and here I'm going to click New, and I'm going to select Java. Let me make sure that's actually showing on the video here. Click Next, and I'm going to create a working set name called Projects 1. And I'm going to click the Add All button to say that all the projects that are open should be part of this working set. So a working set, or at least the way I use it, is really nothing but a collection of projects. Let's click Add All and click Finish. So I'm back on this dialog here. If I click OK, nothing's changed. But let's do that again and create another working set. Let's click the down arrow and go to Select Working Set. And again, I'm going to click New, select Java, click Next, and I'll create another working set called Projects 2. And I won't add any projects to that. I'll just click Finish and click OK. Now I've got two working sets of projects. So if I click the little down arrow another time and click Select Working Set, I can select projects 2 or 1 or both. So let's try projects 1, and that's got all the projects in it because I added all the projects to working set 1. If I click the down arrow and go to Select Working Set Projects 2 and untick Projects 1, then it's blank there. It's sort of cleaned it all up. Let's close that. So my projects are all still there. It's just that they're hidden. So that's really useful because if you've got lots of projects open, you can decide which ones show at any given moment. Don't forget you can also just right-click them and close them, but then the icon would still be there in that case. So this just helps you organize your projects. And one last thing that I want to show you quickly, which didn't work so well in the dark theme, unfortunately. It was usable, but only just due to sort of clashes of font colors, is this task list. So I can add tasks for myself here. If I click, hopefully I can remember this, New Task, let's try that, and select Local and click Finish, I get this view coming up, this task view. Let's create a task for myself. So I want to make another video about primitive types. video. Let's say that's a task for me to do that I want to make later on. And I could select a date when it's to be completed, among other things. So here, but I won't do that. You can do it if you want. And this is what I found currently didn't work very well in the dark theme. You could use it, but you couldn't see these numbers unless you clicked on them or any of this. So that was quite confusing, but I won't use that anyway. What I'm going to do is just save that. And you can see it's here in the task view. It's appeared there. I can add categories as well. So if I click this little down arrow, let me get that into the middle, by the new icon, I can go new category. I'll create myself a category called videos. Click OK. Maybe I can drag this task into that category. Let's try. Yeah, that worked. Or you can select it when you create a new task. You can select category if you've created categories. And you can mark tasks as complete. So you can, probably one of these buttons does it. I don't usually use this a lot, but let's right click it. We can go mark as complete, and then it gets a line through it. Or we can right click, mark as incomplete. So it's quite useful, quite a handy thing. And if you don't like that, you can just get rid of it if you want. You can just click that arrow. It's gone. Get rid of the outline as well if you're not using that. Let's get rid of this task view and go back to the console. Let's maybe open a file. And if you do all of this and then you get confused and you want your default windows back, you can go to Window, Perspective, Reset Perspective, and it will bring them all back. Okay, we'll leave it there for this video. Try those out for yourself. So we've got working sets and tasks and themes if you're interested in themes. Okay, so until next time, happy coding. Hello, in this video we're going to look at while loops in Java. So looping is where we really start to leverage the power of programming to change what would otherwise be extremely repetitive or even impossibly repetitive tasks into something we can just get the computer to do automatically. So what I'll do here, since I'm using Eclipse and since I don't want to see all these projects, I've created a new project called While Loops for this video. I'm just going to click this little down arrow by the Package Explorer, go to Select Working Set. I'm going to select Projects 2, which doesn't have any projects in it at the moment. This is what I created in the last video. Click Edit, and I'm going to say that I want while loops in this working set. Click Add for that, click Finish, and I just want to see the Projects 2 working set. So I click OK, and there we go. That's cleared things up a lot. Okay, so I've got a blank project here, and I'm going to output some text. So sysout control space and hello. And let's run this project. So it just says hello, nothing spectacular there. Now, a while loop looks like this. So I use a Java keyword, a reserved word. So it's a special word in the Java language, and there aren't all that many reserved words in the Java language, but this is one of them. And we can already see some others, for example, public and class and package. So let's type while. And next we've got two round brackets like this. And then we've got an opening curly bracket on the same line. It's on the same line because of the code formatting convention that I'm using. You could be using a different one, but I wouldn't recommend it. And then we hit return, and Eclipse has actually put in the closing curly bracket for me. Now, what's this going to do? Well, we're going to put stuff between these curly brackets. So in this code block, between these two curly brackets, we're going to put statements that we want to run repeatedly over and over again. And we have to have some way of saying how many times we're going to run them repeatedly. And in this case, what I'm going to do is something that you don't usually do in a computer program, but we're just learning here, so it's fine. I'm going to make it run forever, or rather until we stop the program. And to do that, I'm going to say while, and in the round brackets, I'm going to put true. What's true? Well, that's a good question. You know what? We'll tackle that in a future video. But we have a primitive type in Java called Boolean, and it can take the values true and false. So like an integer can take whole number values. The Boolean types of variables can take these values true or false, just one of these two values. And here we're using true. So that's saying while true is true, in other words, keep looping. And the value true is always true, so it will loop forever. Don't worry too much about this. If this sounds baffling, I'm almost managing to confuse myself. Don't worry about it for the moment. But we'll be looking at much more sophisticated while loops later on. For some reason, I've got an aeroplane going past. It always happens when I make videos. Okay, so what I'm going to do here is I'm going to select this system.out.println hello, and I'm going to just cut it. So Control X or Command X on the Mac. And I'm going to paste it between these curly brackets. That didn't go so well. Let me try again. There we go. And just to make sure the formatting's okay, I'm going to run the auto format, Control Shift F. Okay, that removed a few blank lines. So we're saying while true is true, in other words, while forever, output hello. And if we run this little program now, then it outputs hello over and over again. It's going to keep doing that till I stop it. And probably my computer fan will start going pretty quickly because it's going to be using up too much processing power. I'm going to stop it by clicking this red button in the console. That stops your programs. So it's now stopped. And I don't know if you can hear it, but my computer fan is kicking in. So it's not good to let these programs run for too long. Better if you just look for the sort of grayed out run terminate button in the console there, and run it and then quickly stop it again. I'm not actually sure if this can be stopped. If I click in the console, no, I do Control C. In a normal console, typically Control C might stop that program, but here it's doing nothing. So I'm just going to use the terminate button. Okay, so try that out for yourself. Try creating this little program, and before you run it, so you don't end up having to forcibly quit Eclipse or something, make sure you can see this it's grayed out at the moment, terminate button in the console. And then when you start seeing hello being output, hit that terminate button because you don't want this to overheat your computer. Okay, try that out for yourself and verify it works, and we'll be looking at some more stuff relevant to this in the next video. Okay, so until next time, happy coding. Hello, in this video we're going to take a look at how to terminate our while loops from our program. So in the last video we saw an example of a non-terminating while loop, so a loop that just keeps going forever, an infinite loop. In this video we're going to make it actually terminate. So let's start by, here I've got a new project which I've called loop conditions, and I'm going to recreate a while loop. So it's worth typing this a few times yourself so you get into the swing of typing it. Let's write while true, open a curly bracket, and then make sure the curly bracket's closed. And let's output a system.out.println hello. I'd strongly recommend typing this out several times because it will really help you. You've got to sort of memorize these constructs, but not by just looking at them and thinking, but rather than by typing them a few times. That really helps. Okay, so what we'll do here is above the while loop, and it's really important that we do this above the while loop, I'm going to declare an integer variable. I'm going to call it int counter, and I'll set it equal to 0 to start with. Let's output the counter in our system.out.print line. In fact, let's write in here, well, let's use printf just for some practice using it. So here, instead of hello, I'm going to write counter : just for some text, and then I'm going to put %d. And then let's finish it with a \n to create a new line after each time this runs. So that the first argument is this string with a format specifier in it, %d. And after that, I'm going to write comma counter. All right, so if we run that as it is, we're just going to see 0 printed over and over again. So let's look. Terminate it with the red button there. So it just says counter 0. But now within the loop, I'm going to go underneath where I wrote system.out.printf, and I'm going to say counter, and I'm going to assign a new value to counter. So I want to use the assignment operator. And the new value is going to be the original value, counter, plus 1. So now, every time the loop goes round, it'll give this new value to counter, and the new value will be the original value with 1 added to it. And that's going to mean that the counter is going to increase 1 by 1. Let's run it. And we can see we've now got huge values very quickly being output here. You might have a low value if your computer's a bit slower. If you've got an even faster computer than me, that you're going to get more numbers being output there, probably. All right. We can use this to terminate our loop. And by the way, this is not the only way we can do this, but for the moment we'll leave it at this because it's already quite puzzling by itself. It's not an equation, remember. We're literally saying, okay, take this value. So it's best really in a way to read it from right to left. So we're saying take counter, whatever the value is, add 1 to it, and then we're going to assign that value back to the variable counter. So if counter is 0, we add 1 and we get 1, and then we assign the value 1. Well, didn't mean to do that. We're going to assign the value 1 to the variable counter, so counter is now 1. That's why it's incrementing like that. That's why it's increasing. We can use that to terminate the loop if we change this to while counter less than 10. All right, so this is a less than symbol. And what this is saying is do the loop while it's true that the value of counter is less than 10. All right, so I'm going to make some more remarks about this in the next video. But for now, just type this out. And even if it's puzzling now, it will gradually start to make sense. But typing is really, it's almost like 90% of the challenge in a way, because you type these and you become familiar. And gradually, I suppose the thing is, it's a lot easier to understand a program if it's already in your memory. If you already remember what the program looks like, it becomes a lot easier to understand it than if you're also struggling to remember what different bits it has. And when you type it out, that forces you to pay attention to every single character in the program, and that really helps. So you notice here we've got a semicolon. You could easily forget that, easily forget these semicolons, but by typing them over and over again, you just get used to putting them in. You remember that they're there. So typing programs and running them, it's really, really important. So now if we run this, we see in the console, we can actually make this console bigger if I drag it up. We've got counter 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 10 iterations in total. So there's 1 to 9, but there's also 0. So we've looped 10 times. And we carried on looping as long as the value of counter was less than 10. So when it was equal to 10, what happened was the program said, okay, while 10, because counter eventually equaled 10, is less than 10, do the loop. And it said, well, it's not true that 10 is less than 10, so I'm not going to run this. So when this is true, if while finds that this condition is true, so that the counter is less than 10, it will run what's ever in brackets once, and then it goes back to the beginning and checks the condition again. And if it's still true, it runs it again. Eventually here in this program, it's finding that this condition is not true, and then it just does nothing, then your program carries on to the lines after the while loop. Don't puzzle about that too much. For now, the important thing is type this out and get it working. And if you want a little challenge, try to write a program that outputs, let's say, the word hello or whatever you like, exactly 5 times, no more and no less, exactly 5 times. You could also make it output some number, but you don't forget you're going to need this in order to stop the loop. To stop the loop, you need that, and you need that. And you also, another place that beginners often go wrong is they put this variable declaration and assignment to 0, that initial variable declaration, they put it inside the loop, so inside these curly brackets. And if you do that, counter will always be 0 and it will never stop running. You've got to have this outside the loop, you use it in this condition, and very important, you increment it, which means increase it basically within this block. And that's where your system.out is also going, or system.out.printf in this case. So try that for yourself, and then try to create a program that outputs some text exactly 5 times, just for an exercise. Okay, so until next time, happy coding. Hello, in this video I just want to go over this basic while loop a little bit more. So I'm going to even, I think, repeat a little bit of what I said in the last video, because this is really an important topic. Now, hopefully you've tried out this code. It's really important to do that. And hopefully you've tried the little exercise I gave you to make the loop execute exactly 5 times instead of 10 times in this case, or make it execute some particular number of times of your choosing. It is only with typing it repeatedly that you will gradually become familiar with it. And yes, we'll be explaining everything that happens here, and you'll gradually come to understand all the individual elements of it much better than you currently do. But even so, it's important to type these things out to sort of, that will really help you remember them. And effectively, you've got a sort of recipe here, so that if you want a loop that executes a certain number of times, you know what to type, and then you don't even necessarily have to understand it, but eventually, certainly you will. So as we've seen, we've got this while loop, and it's going to execute this code block repeatedly, or it might not execute it at all if the loop condition here is never true. This will never get executed, but typically we're going to execute it at least once, and probably several times. That's the point of a loop. And after the while loop is finished running your code block, then whatever statements are below, it's going to carry on. Your program will carry on executing those. And we've seen that to actually terminate the loop, we start with a variable declaration and we assign a value to it, typically 0. And then usually what we do, or perhaps most often, is we say run this loop as long as that counter is less than some value. So if I were to put 5 here, this code block would execute exactly 5 times. And the reason is that, the counter starts off at 0, and then this would be true for the values 1, 0, 1, 2, 3, and 4. Remember, we're incrementing the counter, increasing the value of it every time we go through the loop. When counter is equal to 5, it would stop. This is a little bit confusing because we're saying while counter is less than 5, and yet somehow the loop executes exactly 5 times. And the reason is that we start at 0. So it executes for the value 0, 1, 2, 3, 4. Instead of, as you might expect, 1, 2, 3, 4, 5. So that's just a little bit confusing. But basically, if you want a loop that executes, 63 times, you'd put 63 here. So it's pretty simple. It's really important to type out this, even a few times if you can be bothered. Try to type it from memory or by looking at the code as little as possible until you can actually write a loop yourself. That's a good thing to do if you feel like looking at it, doing it, I should say, because as I've mentioned, a lot of learning just occurs with sort of almost like muscle memory. Just by typing it again, you've got a little recipe here for how to execute a loop a certain number of times. And I know at this point, if you're new to programming, you're going to probably still feel a bit confused, quite possibly. If you don't, that's great, but it will be normal to still feel confused. We're going to be looking at all the different elements of this loop in more detail and in other contexts, so you'll become familiar with them. But even if you do feel confused, by sort of learning this as a little recipe, then you've got something you can use, and then you can improve your understanding of it as time goes by. Okay, so one important element of this is that we must increment, or in other words, increase the counter as we go through the loop. Otherwise, this condition will never be false, and the loop will go on forever. We have to remember to increment it. Increment just means increase, usually by 1. And there's also decrement, which means decrease by 1, and we're going to be looking at those. In this case, so we've got this expression which, as I've noted previously, can confuse beginners because it looks a bit like a mathematical equation expressing equality. It looks like it's saying counter is equal to itself plus 1. That's not what it means at all. It's really important to realize that in Java and a number of other programming languages, a single equal sign doesn't express equality, it expresses assignment. It's the assignment operator. And with the assignment operator, it's typically best to look at the right-hand side first and work out what that is going to amount to. And then that's going to get assigned to whatever variable is on the left-hand side. So in this case, we take the variable of counter, whatever it happens to be at that moment, we add 1 to it, and then we assign it, or we store that value in this variable on the left-hand side, which also happens to be counter, but that doesn't cause any problems. So it's like we're taking the value of counter, adding 1 to it, but that doesn't actually change counter. This bit doesn't change counter. You're just using the value of counter and adding 1 to that, and that's kind of stored in the computer's memory temporarily. It's this assignment that actually takes that new value, counter plus 1, and then stores it back in counter. If you are still confused, don't worry, that's normal. Your confusion will gradually clear up. One thing I noticed was that there's with Eclipse, I've been using working sets, which I don't use that much, to be honest, but I thought it would make things less confusing here. When I create a new project, it doesn't seem to automatically add it to the working set. I think that's a little Eclipse bug. Maybe it won't happen in your version, because when I go to new Java project, there's an option there to add project to working sets, and the one that I'm using is selected by default. But even so, I'm finding that my project ends up invisible. To see it, I can click this little down arrow, go to Window Working Sets, and I see all projects. If I don't do that, if I just stay on the working set I'm in, what I'm finding I have to do is click the down arrow, go to go to Edit Active Working Set, and then I can see the project I've created, and I can add it to my existing working set, the one I'm using at the moment, the active one. So you hopefully won't have that Eclipse bug, but if you do, if you're creating projects and they don't appear, click the down arrow and go to Edit Working Set and just add it with the Add button here. Okay, we'll leave it there for this video, and what we're going to do in the next video is look at various ways of incrementing variables, because it's such an important topic. We're going to be using it over and over again, and gradually I'm going to introduce you to things like operator precedence, but sort of bit by bit. This is a complicated topic, and pretty soon we're going to get on to looking at other fundamental building blocks of computer programs, like the if construct and other types of loop, this sort of thing. Okay, so until next time, happy coding. Hello, in this video we're going to look at various different ways of incrementing and decrementing variables. So we've seen that in our video on while loops, that we had to increment a variable. And that's such an important thing to do. And there are various ways to do it. So we're going to look at some of them here. And that's going to sort of, although it might not seem very important now, we're going to find that this is going to be quite enlightening as we progress through the course. So let's start off with a variable here. I'm going to make it of type int, and I'm going to, let's call it just count, and set it equal to 0. So what we did to increment our variable for our while loop was we wrote this, something like this: count equals count plus 1. And we've already gone over that, so I won't go over it again. And then if we output it, then okay, it started at 0, and so it's going to be 1 now. And if we just run that, we can see the value 1 in the console. Of course, if I started it at something else like 11 and I increment it, it will be 12. So there's no great mysteries there. Nothing special about 0 here. Now, there are various other ways we can do that. So one way is we can use the same operator that we previously used with strings, plus equals. So I could say here, let's increment it further. So I could say here count plus equals 1, and then we'll output it. So what we're doing here is we start off with count at 0, and then we're adding 1 to it by the most basic kind of simple method. We're outputting it, and then we're adding 1 to it by another method and outputting it again. So we expect to see 1 and 2 in the console. Now what this does is plus equals is exactly equivalent to count equals count plus 1. It's equivalent to that. It's like a sort of synonym for it. The plus equals operator takes the existing value of a variable and adds something to it, or it kind of looks like it does that, at least. With strings, you use it to concatenate more text to an existing string, basically. And in fact, with strings, what you're really doing is creating a completely new string and assigning the original string reference to refer to a new string. That's not important. We'll leave that aside for now, but I just wanted to mention that. So yeah, we're taking count and we're adding 1 to its existing value using plus equals, and we'll just run that. Let's run it. So we've got 1 and 2 coming out in the console there. So let's increment it by yet another way of incrementing variables. Let's do count plus plus semicolon. So this is it's the increment operator. There's some subtleties to this, but I'm going to leave them aside just for this minute. Let's just output this already. So that does it. In this case, it does the same thing as these other statements that we've got. It's just going to increase the value of count by 1. So now with these statements here, you don't have to increase the value of count by 1. You could increase it by anything you like. We're just specifying 1 here as it happens. In this case, it specifically increases the values of integers by 1. So you can't use it to increase them by 10 or something. It is going to be 1. So what we expect now is to see that after we've done that, and if we print it out again, its value will now, at this point in the program, it will be 3. So if we run this, we see it's 3. So we've got 1, 2, 3. Another thing we can do is this, plus plus count. And don't forget the semicolon, of course, as usual. And if we output that, this does almost the same thing as this. So if we run it, indeed it's increased the value of count to 4. Now this is called the postfix version of this operator. Postfix meaning after, it's kind of fixed on after the variable. This is the prefix version. Prefix meaning, well, a prefix, it's fixed in place before the variable. There is a difference between this and this, but we won't look at it in this video. We'll talk about it in another video. So we see here that there are 4 different ways that spring to my mind, at least, that we could increase or increment the value of a variable, of an integer variable. First way is this: count equals count plus 1. We can also do count plus equals 1, or count plus equals whatever other number we want. And then we can use a postfix increment operator, count plus plus, or we could use a prefix increment operator, plus plus count. So I would suggest trying those out, but actually, before you do that, let's look at decrementing the variable as well. So I can do the same thing in reverse. For every increment operator, there's for every way of incrementing this, there's also a way of decrementing it. So if I say count equals count minus 1, that's going to take the value of count, subtract 1 from that value, and at the moment we're then holding that new value temporarily in memory, and then assign that new value to the original variable. So this has the effect of subtracting 1 from the value of count. I'm giving you explanations here, but that is to try to, hopefully you'll understand bits of my explanations at least, but the real learning will take place when you type this out and try it and even experiment with it. So if we now run this, then we get 1, 2, 3, 4, and then we decremented it and we've got down to 3 again. We can also decrement using this kind of a technique. So instead of plus equals, we can do minus equals. Let's do count minus equals 1 and sys out. Let's run this. So now it's down to 2. So this is precisely equivalent to this. Let's just format that to get rid of that blank line. Well, that doesn't work. Oh yeah, it does. Okay. So this and this mean exactly the same thing. We can also do count negative negative or count minus minus. So that's the postfix decrement operator. And that works just fine. So if we run this now, it's down to 1. And finally, we can do a prefix decrement operator. We could do this, count minus minus count. We could have used any of these methods in our while loop, sorry. Well, any of the methods that increment it, at least. So let's run this, and we get down to 0, which is what it was to start with. And to make that clearer, actually, after I initially assign the value 0 to count, let's put an initial sys out in there. So it starts off at 0, we increment it 1, 2, 3, 4, and then we're decrementing it by various methods, 3, 2, 1, 0. Now what I'd suggest is that you type all of these yourself, either one after the other, or just try them. Just create a program, increment a variable in it like this, run it, check that it works, and then change that to this. So get this to work. Once you've tried them all out, try to write this program from memory. That is, start with a variable that has some value, for example 0, and then increment it by each of the 4 different methods, and then outputting it every time afterwards, and then decrement it by each of the 4 methods, outputting it every time. If you can be bothered to do that, that'll help fix all these different operators in your mind, and then you'll feel more confident when we actually start using them. So in other words, try to replicate this program from memory, but I'd probably suggest, unless you're feeling confident, that you try each of them out individually before you try to do it all without referring back to this code. Have a go at it and see how far you get. Okay, so until next time, happy coding.